Good evening and welcome to the shed. Got an interesting one for you again. I was in a stream last night talking to a guy called Red on News Unit's channel. Just totally out of the blue, he just started talking about flat Earth. And to start with, I thought, he's not a flat earther. And then I was like, is he? He is. No, you're not a flat earther. So I went into this. It's a strange one, really, because all he did is he just kept throwing questions at me all the time. When I was addressing these questions that he was giving me, he just went, yeah, okay, right, and went on to the next one. It was like, you're not even addressing what I'm telling you. You're just going on to the next one. But anyway, the conversation was pleasant, nice enough bloke. No faults with him as a guy to have a conversation with, I suppose. Just some very strange beliefs. So yeah, hope you find it interesting. So this is another one for the channel, and today it's going to be all about the flat Earth. So I hope you enjoy. You just bear me with me while I just sort this out. I'll have to have a look because I can't remember.
So, Paul, have you seen the ice wall down at Antarctica?
Oh, God almighty. You're not a flat earther, are you?
Yes, sir, I am.
No, you're not.
Hey, did you go out and look at the moon this evening? The moon and the sun don't line up this evening. They're about off by about 15 degrees. But you're probably, it's already dark for you. Around 4 or 5 o'clock, the moon was tilted up in the air about 15 degrees, and the sun was already starting to go down behind the horizon, so to speak.
Right.
The two of them do not line up with each other, and you can see this with your own two eyes. You can tell that NASA is lying to you if you look closely enough at certain things. You look at a chemtrail going across the sky, it should curve down 66 feet.
You're not joking. You really are a flat earther, aren't you?
I sure am, man. There's enough proof in my mind that the ISS...
There's no proof at all for the flat earth. None at all.
There's tons of it.
Now we're gonna have a flat earth debate. Here's a flat earth. This is debate time, ladies and gentlemen.
Yeah.
Red pill.
Give me your best.
On flat earth. Go at it, guys. You got it.
Listen to this. The ISS is supposedly going around the Earth 17,100 miles per hour. How many feet per second is that? 25,080 feet per second. Do the math. Now, a bullet shot from a gun is about 2,000 to 2,400 feet per second.
Yeah.
The ISS is going 10 fucking times faster than a bullet shot from a gun. I can't see a bullet. I can't catch up with a bullet. How in the fuck am I going to catch up with something going 10 times faster?
Who's asking you to catch up to it?
Do what?
Who's asking you to catch up to it? What do you mean?
Somebody has to dock with it in order to get into the ISS.
Yeah, but they end up going the same speed, so then they catch up to it. So yeah,
they're going 10 times faster than a bullet, and somehow they can catch up with this thing and slow down enough to.
What's the problem with going 10 times the speed of a bullet? I don't understand what the problem is with that.
Well, you can't even see a bullet. How are you going to see a?
The only reason you can't see the bullet. The only reason you can't see the bullet is due to the sheer size of it. If you get a slow motion camera, you can see a bullet. So it is there. It's the fact is, it's just going that fast that your eyes can't pick it up. That's the only difference. If it was bigger, if that bullet, instead of being that big, was the size of a car, you would see it go faster.
Yeah, let's move on to something else.
No. Let's stick with this one. Let's stick on one subject at a time.
Well, I mean, I pretty much covered that. In my mind, you can't do it.
Why? Because you're looking at a bullet which is that big, and you're looking at a space station which is twice the size of 2 football fields, or twice the size of a football field.
I hear you.
You can see that.
I'm probably not going to convince you on that one. That's why I wanted to move on to the next one.
Well, can you not understand that if you've got something like that whizzing past you, you're not going to see it. But if you've got something
bigger,
the size of 2 football fields, which is traveling overhead, you're going to see it.
Yeah, I can understand that part. Now, the temperature's up there. The temperature's up there. On the cold side of the Earth, they say that up in 250 miles up, it's minus 250 degrees Fahrenheit on the cold side of the Earth, where the dark side.
Yeah.
On the hot side of the Earth, they say it's plus 250 degrees Fahrenheit.
Yeah.
Now, you go around the Earth every 43 minutes, you go from one side to the other, and then back around another 45 minutes, 93 minutes total, they say. You're doing a swing of 500 degrees every half cycle around the Earth. You go cold to hot in 43 minutes. How in the world do those little guys in those spacesuits go from minus 250 to plus 250. Do they have a heater on their back and an air conditioner and a button that keeps on turning a dial that keeps on dialing it so that they don't get cold?
They're inside the space station, so the space station would have its own ambient temperature. And like you said,
I'm talking about the guys that are on the outside of the thing floating around for hours.
Yeah, well, the spacesuits do have pipes going through them. You wouldn't got to Google that. They do have pipes going around which either keep them warm or keep them cold. So yeah, that's not a problem.
Yeah. Who was the first person on the moon?
Neil Armstrong.
The cameraman.
No, the cameraman.
Exactly.
No,
the cameraman was. He's right.
The camera.
I'll give you that much, Red.
No, because the camera was on the spaceship. It wasn't on the moon. So when
right,
Neil
how did they get the dune buggy up there?
It was foldable.
Why do I have a picture of 3 astronauts on the moon with their helmets
I think
on?
they got those relics. I went into the
Smithsonian. Why do you have what?
I have a picture of 3 astronauts on the moon with their fucking helmets off. It's supposed to be 260 degrees Fahrenheit on the surface, on the side towards the sun. That's where they landed.
You've got a photo with the helmets off.
Yes. Now, is this them on the moon, or is this them in a desert out in Arizona somewhere practicing to go to the moon? We don't fucking know, but that's what they display in this picture.
But I would say that it would be they didn't have the helmets off when they were on the moon. No.
Well, this picture shows all 3 astronauts with their helmet off.
But like you said, they did use to train out in one of the deserts, didn't they? So is that a picture from that which people are trying to say this was when they were on the moon? So
they should have been honest with us and said this is not on the moon. This is in Arizona in the practice. They should have been honest.
Right. So get the original photo that's been published by NASA, and what do they say it is?
Well, I haven't went that far yet.
Right.
I'm just saying I've got it in my possession. I could even display it on the screen, but I'm probably going to get Dave all.
No, you're fine.
Fair enough. So what else have we got for then? That you said you've got some.
At
the moment, all you've been doing is arguing about the space landings and the space. So that none of that has got anything to do with the flat Earth, to be honest.
Well,
so
what really does? I'm getting liquored up tonight. I'm going to make another one of them.
What really does is the curvature of the Earth formula. Every mile squared times 8 inches. So if you go around the surface of the Earth, you're supposed to go down, dip your nose down 8 inches every mile in an airplane. Yep. If you're going to fly around, so every 1 mile you would dip down 8 inches. So you go 10 miles, it's 10 times 10 is 100 times 8 inches. Divide by 12, that's 0.666. That's 66 feet in 10 miles. 66.6 feet in 10 miles. So
how did that come up to 666? Like that's some kind of
a lot of them try and get the 60. A lot of them try and get the 6
8 inches per mile divided by 12 inches per foot.
Do you realize I'm a pilot? Do you know that?
Yeah. Okay. Have you ever seen curvature?
So am I. I'm a commercial multi-engine instrument. Yeah.
I'm not commercial, but I'm just saying. Did you realize I am actually a pilot?
That's
what do you fly? What do you fly? What kind do you fly?
Now, when you fly from the East Coast to the West Coast of the United States,
it's about Cessna 150 and PA 28.
Yeah. Okay. Seats and seatbelt, test off, fuselage, vector on, brakes test, set radios, electrical off, master switch, prop clear, start, mixture rich, throttle quarter open, clear, start it up, 1,000 RPMs, warm it up, go out to the runway, do your run up, 1,700 RPM, checks the right mags, left mags, flaps, everything, ailerons, flight controls free and correct, everything ready for takeoff. All right, Cessna 24 Romeo ready for takeoff. All right, 24 Romeo, runway 33 position hold. Different position, 3-3. Clear for takeoff, fly runway heading. Power checks, airspeed's live, 50 knots, rotate, climb to 70 knots. Yeah, man, you're a pilot. Good for you. Look at that. I know how to fly those. I got a lot.
If you did a time lapse on that and look at the horizon, would you see yourself dipping down every 8 inches every mile?
Yeah. Why would I? This is the thing, right? Whenever I talk to somebody who isn't actually a pilot, Why do you think I would need to dip?
Because the Earth is curved, they say.
Yeah, but do you not realise that I'm flying in a barometric air pressure? So it's to do with the air pressure that I'm in.
Yeah,
so
but
there's
you don't want to fly off. You don't want to fly off.
Actually, I've been up at 41,000 feet, and I actually saw the curvature with my very eyes.
Yes, you can actually see the curvature, and you can see it on a commercial flight. I know what you're going to say. Neil deGrasse Tyson said this. Yes, he did. What he's talking about is that it's that small. It's not like you see a curve, but you can see a very slight curve.
Yeah, you can see a slight curve at 41,000 feet. I was up there in a 757.
Yes, you can.
We were up there.
If you go to Earth Curve,
I was in the cockpit. I flew in the cockpit, man.
Yeah.
If you go to Earth Curve Formula website, you can plug it in. If you say it's zero height, up
I actually flew a 757. I got 757 time.
Right.
Wow.
Very good.
For real. I was in a simulator. That's considered actual time.
Yes, it is. Yeah.
Yeah, I was in a multi-million-dollar simulator for US Air, and is that realistic? Let me tell you. I got about 2 hours in that thing. Yeah.
Anyway, if the radius of the Earth is supposed to be 3,959 miles average, give or take a couple miles for the oblate spheroid, they call it.
Yeah.
Average.
Yeah, over a couple of thousand miles, it's perfectly fine. Yes.
Yeah, but anyway, they say that the curve formula, if you look up the math on there, the parabola formula is fairly accurate up to about 200 miles. So if you do,
I would say it's accurate for more than that.
Yeah,
but
it probably is within a couple inches or with a couple feet. I mean, it's up to 200 miles. We can say it's trustworthy.
It's accurate enough. Yes, it is accurate enough. Yeah.
100 miles would give you 6,666 feet of drop out below the horizon if you were looking straight at eye level at zero. Now, if you're up six foot for a normal man, it's going to be a little different. But the formula takes that into account on those websites. So then you go 100 feet up, it's going to be a whole lot different. But at several 100 feet up above Chicago, they looked out with an infrared camera and saw the Rocky Mountains 700 miles away. That's the world record that we know of right now. You can look across Lake Michigan, 59 miles away. Joshua Nowicki took a camera picture of the Sears Tower and a couple other buildings over there in the distance, 59 miles away, and hardly any of it was buried down below the horizon. The whole building should have been buried. It's at 59 miles, you have 59 times 59 times 0.666. It's probably 1,000 some feet that thing should have been buried. I'm not going to do all the math in my head, but let's say at 100 miles, it's 6,660 feet. That's over a mile that something should be buried at 100 miles away.
I mean, the ones that you're telling me about now, that obviously I can't comment on them. I've not seen them. I can't comment them on them. But there will be a perfectly rational explanation. Now, I do remember as a kid, I was about 11. No, I would have been older than that. I'd be probably 12 or 13 year old. We went on holiday down south. You won't know this in the UK, but we went all the way down south from Yorkshire. And you can look across when you get down south. You can look over into Wales, going across the channel that goes into Wales. Anyway, we turned up at a what they call it, like a pub, an inn. I was about 12 or 13 year old, so there was me, my mum, my dad, my brother, and my sister. So we were kids. My mum and dad was there. We comes in. Anyway, while we was there, these people turned up. And they had all the cameras and tripods and all that, and they were all booking into the hotel. And my dad just happened to talk to them. He went, "Oh, what's going on?" He went, "Oh, there's a over the next couple of days, the conditions are going to be right where we'll be able to take long distance photography due to the refraction rate and all this lot." So they turned up to do that. So refraction is a thing, and this went back years ago. So you can take photos of things that are a further distance away, because at 69 miles or 60 nautical miles, an image only has to be refracted up 1 degree and you can see it. So 1 degree is not a lot, but when you start talking about in feet, and it has to be lifted up X amount of feet, it sounds a colossal amount. It's 1 degree it needs to be lifted up over a period of 69 miles, and you can see it.
Yeah. What David's showing there on the screen is Nikon P900 camera zooming in on.
Flat Earth's camera of choice.
Well, yeah, I mean, you got to have something that's able to zoom in digitally. You can see that it totally disappeared.
No, because what's happening is if it was a bigger ship, you better see it. If it's a small ship, you can't see it, especially with the camera when it's that far. You could probably still see that with your eyes, but the camera won't pick it up. You zoom in, but you will not get the where the bottom of the boat has started to disappear. You will not get that to rise up no matter what. So if the boat starts to go over the horizon and you can only see half of the boat, you will never bring the other half back, no matter how many times you zoom in. Now, if you can show me that, I'll be impressed. So I want to see half the boat missing. You zoom in, and it comes back. The other half comes back. I bet you can't show me that.
No, you're never going to overcome all of the refraction that's out over the water. Especially
you won't overcome anything. What we'll do is you'll make the image bigger, but you won't be able to see. Or I can only see, I don't know, a quarter of it. And then as you zoom in, I can see half of it. You won't. You look at that there. None of them have got any smaller or bigger. They've got smaller or bigger, but you're not showing more of it. So that's all you can see. When it starts to zoom out, does it start to go less and less? I don't think it will. No, it doesn't. It just gets smaller. You're not losing any height on it.
Yeah. But something like that far away should have been buried the whole daggone thing and not just showing the top portion. 66 feet in 10 miles, 20 miles is 266 feet. You shouldn't 20 miles away. I think that zoom right there a while ago probably zoomed in on something that's 15 to 20 miles away. But I'm not going to prove it just by talking about that. But
there's no way is that 20 miles. There's no way is that 20 miles.
Yeah. Anyway, if you look left, if you go up in a high-rise building down close to the beach, you should be able to look left and right and see at least 5 miles left and 5 miles right. Am I correct?
If I do what, sorry?
If you go up in, like, say, the 15th floor of a hotel down at the beach, look out at the water, out of that window, you should be able to see 5 miles to your left, 5 miles to the right, at least. That's 10 miles right there. And that 10 miles on your left side, you should see it drop down 33 feet. On the right side, 33 feet with a curve upwards in the middle. So you get a total of 66 foot of drop in 10 miles.
Yeah, so from either side. So you get 33 miles on this side and 33 miles on that side. So there'll be a
33 feet, yes.
Drop. Right. But if you're looking over a 5 mile distance, you are not going to notice 33 feet. There's no way you're going to notice 33 feet over a distance of 5 miles. Not a chance.
Well, it should be fairly obvious that there's some curvature. But I'm telling you, you go down to the ocean and you do not see anything curved like that. You see,
I wouldn't expect to see it neither unless it was on a smaller Earth. I wouldn't expect it.
That's
I would not expect to be able to see 5 miles out there. So left to right,
I'm
5
telling
miles.
You that is what we are.
33 feet. That's tiny.
That's what we are to expect on the curve of the Earth that they tell us. 3,959 miles.
Right, stop that picture there. Stop that there. Have I got something here? You're not going to be able to see it, but put it back. Put it back.
You trying to lay a straight edge across it?
Yeah, I'm there. There's a curve. There is a curve.
Slight curve.
Ever so. I mean, I'm talking. You're talking like 3 or 4 millimeters. But yes, there is a curve.
Yeah,
yes,
it might be infinitesimally, right? But over a big long distance, you should expect 66 feet of curve in 10 miles.
In 10 miles, can you imagine how small that is over a 10-mile distance? How small that's going to be? 33 foot.
Every mile, 8 inches. You should be able, if you're flying in an airplane, doesn't that make you feel like you're going centrifugal force? You would constantly feel that in your stomach if you were doing 8 inches every mile.
Did you ever take a piece of string or something and put it on a globe and connect 2 points? It actually goes over the great circle route, they call it.
Yeah. Yeah.
Mhm.
It's not a straight line like you think it is.
No, it's not.
It's weird.
Yeah.
So anyway,
what else?
if you go from the East Coast to the West Coast, the formula I laid it out in AutoCAD one time, 2,300 miles average from New York City to LA. Let's just say that's an average distance of the East Coast, West Coast. If you plug 2,300 miles into AutoCAD, draw a straight line through from East Coast to West Coast, and then you go up to the hump. It's a 184-mile high hump in the middle of the United States from East Coast to West Coast. Do you feel like you fly over a 184-mile high hump in the middle as you airplane pilot from East Coast to West Coast?
Well, no, because you're flying in a straight line. To you, it's straight. It's such a
Yeah,
small. I don't think you realise what the scale is. If you take a globe and you look on how high above the globe, a school classroom globe, the average globe that you'll get,
Mhm.
the average aeroplane flies about probably the thickness of a matchstick above it. That's all it's flying. That's how high it is. The International Space Station is less than an inch above it. That's literally
like Neil deGrasse Tyson shows that ball, and he says it's like a millimeter above it.
Yeah, it is.
Anyway,
Yeah.
one more question then is as you're flying 500 miles an hour average, maybe in some of these commercial jets.
Yeah.
So when you go 500 miles an hour, how far are you going in 1 minute? You're going about 8.33 miles in 1 minute. In 8 miles, 8 inches per mile squared, 8 inches every mile. So in 8 minutes, at 8.33 miles, you're going down how many inches? You're going 8 inches, 8 inches, 8 inches. You're going about a total of 64 inches in those in that 1 minute. Don't you feel like you would feel a little bit of a butterflies in your stomach going around a curve and constantly centrifugal force?
What six? So basically, what you're saying is every minute I'm dropping 66 inches.
Yeah, about 64 inches in 1 minute at 8.33 miles in 1 minute.
Yeah.
So
when you're
you
in
should feel that.
No, you won't feel that. When you're in an aeroplane, Dave will probably be able to verify this, especially when you're in a light aircraft, right? One of the hardest things to do when you're first starting to learn to fly is keep level flight, right? He'll say, right, get to 2,000 feet. I want you to stay at 2,000 feet. You're at 2,000 feet. Next minute, you're looking at you 2,200. The next minute, you're looking at you at 1,800. Then you're looking at you at 2,500. And it's going like, oh, but you don't feel it. You don't feel it. If you weren't looking at the altitude meter, you wouldn't know.
Making adjustments of the attitude of the airplane. Yeah.
Yes.
Just fine
You do not feel that. You can go 200 foot, 300 foot in less than a minute, and you don't even know you've done
2 seconds. Yeah.
Yes, literally in a few seconds, you can go up 200 or 300 foot. You can come down. Literally the hardest thing, the very first thing you'll do when you learn to fly, when you go in a light aircraft, the first thing you'll do is a pilot will take off. He'll get to about 2,000 feet. He'll talk through, turning left and right and whatever, and he'll say, right, you have control. And you've got control of it then. And he'll say, right, you're at 2,000 feet. There's your altitude indicator. I want you to stay at 2,000 feet. Honestly, you'll go to 2,500 feet. You'll go to 1,800 feet. And you're like that all the time, trying to get it to stay at
without an altimeter, you couldn't maintain level flight.
No, you couldn't. Absolutely, you couldn't. After
hours
and hours,
obviously, you know.
It's like riding a bike. It's like when you can't ride a bike, you can't understand how anybody can ride a bike. You just keep falling off. You fall off. Once you learn how to ride a bike, you can't not ride a bike. I couldn't get on a bike now and pretend I can't ride a bike because I can ride a bike. And like now, if I get into an aeroplane, I'm flying at 2,000 feet. I'll keep it at 2,000 feet. No problem at all. It'll stay at 2,000 feet. Why? I don't know. Just the experience of doing it over and over and over again. I couldn't get it to do what it did when I first started to fly. Going at 1,800 feet to 2,500 feet. It'll stay at 2,000 feet. But you don't feel that difference. You really do not feel that difference. I could take you up in an aeroplane, put blindfolds on you, and I can go from 2,000 feet to 5,000 feet, back down to 1,000 feet. And you won't even know I've altered the altitude.
I can usually feel when I'm going up and when I'm descending. I can usually feel it in my stomach.
You'll not have a clue, mate. If I put blindfold on you and I take off, you will not have a clue where we are. You won't know whether we're in level flight or whether we're.
I can pretty much tell when we're leveled off, and then when we start to go down towards the destination, I can feel us descending.
Yes, you can when you're in a
what picture you
aeroplane.
got there, Ed? What do you got there? What is it?
Do you know?
Anyway,
do
let's
you know,
hear it.
when
This
a
is a picture.
commercial airline, hang on a minute, when a commercial airline is starting to come in, it's on its final approach and it's coming down. How many hundreds of feet do you think it's dropping per minute?
When it's coming down from where?
When it's coming down to land, when it's on its final approach and it's starting to come down to land.
In 1 minute, it probably drops 2,000 feet at least.
Yes.
Mm-hmm.
So if I'm in an aircraft and I'm only dropping 100 feet per minute, you are not going to feel it.
Mm-hmm. Trying to find this one picture here. Cycle through a couple things here. This is a picture of Google Earth. If you go to Google Earth up in the upper side of Russia, you got this little island up here. Why in the world did Google Earth put a crack, and sometimes it's double, all the way up to the North Pole?
I don't know.
Anyway, it ends right at the North Pole. You go check it out for yourself. It's not a satellite image. It's some kind of Easter egg that they put in there to show that they're laughing at us.
I don't know.
This is what a bridge looks like out over water. You don't see it curved down 66 feet and 10 miles.
No, you don't, because what you're doing is that picture's been taken from above. Now take it from ground level and tell me it don't care.
Yeah, well, and also if you go into James Webb Space Telescope stuff, you'll see this kind of stuff in there, and it's even in what they call live.
That's a representation of all the galaxies. That's what that is. That's not.
But they call this a live stream, and I've captured this stuff. And none of these stars ever fucking twinkle at all. How come I
can't take a field trip and go see the ice wall?
Yeah.
When are we going to be able to do that?
Now, this here, what's wrong with this picture?
Nobody can ever
Felix Baumgartner jumped from 128,000 feet, it said. And it showed that much curve out of his window.
That camera, when he jumped out of that camera was not there to show the curve. That there was a fisheye camera. It was there to give you a wide angle view. It wasn't there to con you that was a curve. It's a fisheye camera. That's all it was.
Why didn't they tell us that up front?
Because why would they? Why would they tell you that?
They're trying to deceive us.
No, because if I'm using a fisheye camera, I ain't going to tell everybody it's a fisheye camera.
Yeah.
It wasn't about that. It was about him jumping from that altitude. That's all it was.
Anyway, you go up 121,000 feet in a hot air balloon or whatever they took up with the dog cam. You go up this high, and this is the horizon. It always comes up to eye level, and it's flat. It's fucking flat.
No, it doesn't. No, it doesn't. Absolutely been proved. Absolutely wrong. Go to MC2 it absolutely shows you by using the iPhone. There's an app you can get on the iPhone which will show the level, and know the higher you get, the lower down it goes. What's his name? Oh, he's a pilot. I can't remember his name. And he does it. He shows it. No, the horizon is lower than your eye level. If eye level's there or there or there, to you it's the same when you're looking out at the distance. It does not always rise to our eye level. Just Google. I'll try and find it. Subscribe to my channel. I'll subscribe to yours. Me and you need to have a conversation. We need to have a conversation.
All right. So the lunar module coming back from the moon, it goes through thermosphere, 2,000 degrees Fahrenheit. It catches on fire and it comes back down through there. It supposedly has a heat shield, supposedly.
Oh, leave the link to your channel in here somewhere on the when you get around to it.
I'll do that. I'll do that.
Yeah, I'll put a wrench on it. Just type test in the YouTube channel.
You give me a wrench last time, I think.
Let me make sure you got one. Yeah.
What puts a fire? What puts this fire out before they can deploy the parachutes?
Don't put the fire out. It's not the thing that's on fire. It's the air that's going around it that gets heated up, which is on fire.
And what slows the thing down and to get it to the point where the parachutes don't rip themselves in pieces?
The atmosphere slows it down. When the atmosphere they're at a high rate of knots. That's why it heats up. Is because when it hits the atmosphere, that is what starts to slow them down.
Mhm. Couple things
Yeah.
here of re-entry.
Right, I'm on my
capsule.
channel now. How do I get a link to my channel? What do I do?
Yeah. So are these things the same thing?
Hang on, I'm not watching that. What do you mean?
Look at this one. Look at this container ship going over the horizon.
Can't see a container ship.
Not
You
real
looking at
good.
the same thing I'm looking at?
Yeah, I got yours up, but I'm going to switch over to this other one.
Okay. Anyway, yeah, this shows what gravity is like right there. That last one.
Look at this one here, though. This is a container ship sneaking over the horizon.
Yeah. And no matter how much you zoom in, you will not get any more of that ship to show. You'll make the ship bigger, but you will not get any more that's hidden. You will not get it to come back.
Yeah, and it all depends on which day, though, Paul. Sometimes the refraction is better on some days, and sometimes it's worse.
I don't care. You will never get a part of the ship which is missing to come back. You'll get the ship to get bigger, but you will not.
There's a video on the internet. I think it's called Black Swan. Here's the one I wanted to show you all guys earlier.
Yeah, that's when yeah. So that is, nobody's saying that that's on the moon. That's when, obviously, when they have the moon buggy and whatever, they would have to test it. They used to go out to one of the deserts, which is where they used to do a lot of the testing and stuff like that. So that's just a photo of that. That's on Earth. No one's saying that's on the moon.
Well, they should have made it very obvious.
Well, they didn't really think that people were going to be arguing about the Earth being flat.
Anyway, this if the Earth was really curved, like I was talking about, 33 feet on either side, 66 feet in 10 miles, you should see the bottom part there, not the top.
Yeah, but you would not. Are you telling me that 33 feet over 10 miles would look like the bottom one?
Well,
so hang on a minute. Hang on a minute. You're telling me that the bottom picture is more accurate. So you're telling me that 33 feet is going to look like that over 10 miles. No way is it going to look like that over 10 miles. You will not even see 33 feet over 10 miles.
You should. I can detect what 33
over
feet
10
is.
miles. 33 feet over 10 miles. It's like the height of...
You're standing in the middle. You should be able to see 5 miles to the left if you're up in a high-rise hotel down at the beach.
Yeah.
You look out, you can pretty much see 5 miles to your left and 5 miles to your right.
33 feet is about the height of a lamp column.
Yeah.
Are you telling me you can see a lamp column 10 miles away?
Anyway, what about lighthouses? The sailors in the boats can see light from lighthouses 40 and 50 miles away.
Every time I say something, you won't address it. Can you not agree that over 10 miles, looking at a light column, are you telling me you can see the distance and it's going to look like that?
What's
go
the
back
term
to
you're
the other
using?
picture.
Light,
no,
light
go back
column?
to the other picture. Go back to the other picture. Right. So a lamp column that is on your street is probably about 33 foot. It's probably about 30 foot high as a lamp column, right? Are you telling me
lamp column?
A lamp post, you know, on the street.
Okay, with lamp. Okay, yes.
The street lamp. So it's probably about 30 feet tall. So you're telling me over 10 miles, it's going to be what you show that on that bottom picture. That's the distance you're going to see. You're not even going to see that lamp column at 33 feet.
Yes, of course, it's exaggerated here, of course.
No, you said that the bottom picture is the one we should see.
Well,
and not the
I'm
top
just
one.
saying.
What I'm telling you is the top picture is what you'd actually see, because you are not going to see 33 feet over 10 miles.
No, this here, of course, is exaggerated. This is only 1 mile, probably you're seeing right here, and so it's exaggerated.
So the top one is more accurate then, because you're not going to see 33 feet over 10 miles, and you can't see 33 feet over the 10 miles at the top one. So the top one is more accurate than the bottom. So the top one is more accurate than the bottom one, yes?
Yeah, but the top one, do you see any curvature at all there?
I wouldn't expect to see 33 feet over 10 miles, so no, the top one is more accurate than the bottom one.
Yeah,
you've already conceded that the bottom one is exaggerated, and we've already come to the conclusion that a lamp column, looking at it 10 miles away, you're not going to see it, so the top one is the accurate one.
So if we took in paint and we took a line and drew it from here to here, let's see if I can get, I don't know if I can get it where you can say, look, is there any curvature underneath that line?
No, what I wanted to do is I wanted to put it level with the actual thing, not above it. and then I want you to compress it.
If I can, yeah, I know. As you compress it from left to right,
Yep.
you're supposed to see. Okay, so that looked pretty good.
Yep.
Right there. Okay, so now resize it. Okay, resize and skew. Hold on. Am I hitting the right button there?
I don't know how you do it. I've never done it.
Okay, let's see. Which one is it? This edit view, full screen, zoom out. Now what we want to do is do the
We want to compress the picture, yeah.
left to right. Let me get this full screen here one time. Maybe it's not giving me where you do the 100 by 100%. Rotate. Which one is it? Movie background, image. No. Should be this resize and skew. Control W. I don't know why it's not doing anything. It doesn't want to behave for me today. Magnifier. Anyway, you should be able to take that and scrunch it down.
Yeah, you should, yeah.
Image property.
I've never done it.
See here, width. If you take the height, scrunch the height node. Let's scrunch the width down to 200 instead of that. Let's see if it'll do that. Yeah, there we go. You're supposed to be able to see a curvature on if you scrunch it up, right?
Yeah, and you can do if you look at that. There is a very slight curve on it. Yeah, there is.
Go down to 20. That's too small to notice.
That's
so
too small.
Yeah. Anyway, you're saying that little bit right there looked like a curve to you. So, yeah. It's not conclusive, but I'm telling you, in 33 miles, you should be able. I mean, in 10 miles, you should see 66 foot. You're standing at one end,
which is nothing. Over 10 miles, that's nothing. Certainly, the bottom one is way exaggerated, and the top one is actually the more accurate one out of the two.
Yeah. So, who put that ISS together up in space?
I have no idea. It was. I believe it was joined.
Yeah, going 10 times the speed of a bullet. They put it together. So this is what happens when you get CGI, computer graphics imaging, and over time they've taken all kinds of different supposedly pictures of the Earth. You get all kinds of different colors, sizes of continents.
No, do you? Oh Jesus! Honestly, do you understand why there's different sizes of continents?
It's very hard for me to understand.
Right, I'll absolutely. Right, have you got a globe at home? Have you got a globe?
Let's see. Am I on? Oh, I'm on the wrong page here. Okay, let's go there.
Do you own a globe at home?
I don't need one. I got that right there.
Yeah, unfortunately, that ain't going to help me, mate. Right, let me just show you here. I'll see if I can find it. I did this before. Somebody. Oh, I've got to try and find it. Right, somebody did it. I've got a globe, right? So I took a photo live on I think I took a photo of it close, and then I came away, zoomed in, and took another photo. And the continents are different. The globe will be the same size. The continents will be different. So if a satellite is close to the Earth and takes a photo, the continent's going to look very large. If the satellite is further away and zooms in and takes a picture, they're going to look smaller. Let me just go to it. I do have it on here. So that's perfectly. Because I can replicate that myself, and so can you replicate that. That has been debunked. God, years and years and years ago, that was debunked. It's so easy to replicate that just with a globe and a camera phone. I've got to find it because it was yonks ago when I did it. Somebody asked me. They said exactly the same thing, and I can't believe this still comes up.
We'll try to bring up Google Earth Pro here. If you need to see examples of what you're talking about, zooming in, zooming out.
Found it. Earth. Found it. Right.
So you're saying it's like the further you go out.
Right. Look at. Oh God, you can't see it. Right. Look at that. Yeah.
Yeah. Australia.
That is Australia. Yeah. Look at the size. Look at the size of my phone, and look at the thing. Right. And then I go like that. It's bigger. The globe is the same size. It's bigger. Okay. See it?
So you're doing about okay. Look on the screen. It's about like what I've got shown right there, right?
Do you understand how I've done that? It is the same globe.
Okay.
It is the same globe. It's the same globe. Australia large, Australia small.
Okay. Okay, but now look at the big screen. Look at the big screen
Yeah.
there. Look, I'm zoomed all the way out to 39,000 miles away.
Yeah.
Now you zoom in, and
Yeah.
Australia is going to appear to be
Yeah.
a little bit larger in comparison to
Yeah.
the rest of things. So the further you zoom out,
Yeah.
you can get a little bit more of the globe in there like that.
Yeah.
But you're like this, you still see these things up here at the top.
Yeah.
It's not like it changes that fucking much. Now, I want to show you what I was talking about earlier. You go zoom in here to this island. Why the fuck did they put a crack in here all the way to the North Pole?
They won't do it, but it's a glitch in the composites of the pictures they put on. That's all that'll be.
So inside that glitch, they have stuff that looks like moon rocks down here. In some places, it's a double line. There's black line. Good little glitch there. There's a little thing off to the side. And here's where it starts to go double. And then it goes double again, and then something in the middle.
Yeah, you don't realize it's all composites, don't you? So yeah, it's picked up a glitch. So what?
Well, I'm just saying that they're letting you know that they're laughing at us.
No, they're not. That's you picked up a glitch in it.
What kind of a glitch is that there? That doesn't look like a glitch. That looks like moon rocks or something like that.
It doesn't remind me of the moon at all.
Somebody intentionally put that in there. I'm telling you, it's not a satellite image. It's not a glitch.
No, you found something. So when you go to Google Earth, either you or somebody else has found this thing on Google Earth, and you've put your own spin on what it is with no evidence whatsoever.
Now, I want you to think about this one time. That's 39,000 feet away from the Earth. That's as far as they'll let you zoom out in Google Earth. Now, what if they would let you zoom out as far as the moon is, 238,000 miles? That would really tell you if the moon is really, the Earth is really the same size as what they.
And if you allowed you to zoom out that far, then you would say, why can't I zoom out twice as far? And if you could zoom out twice as far, you'd say, why can't I zoom out twice as far as that?
Yeah. Now, take and extrapolate that. 39,000 miles divided by 238, that's about a factor of 16. So if you took this into paint and you zoomed it down by size of, I'll even give it 17 to say, yeah, look, let's give them 16.6 or whatever the number is. Let's give them 16, the benefit of the doubt. You zoom that thing out by a factor of 17, and the thing appears so small that it's like the moon from here. Now, think about it going the opposite direction. I got a picture of it here somewhere. Where's the moon? All right, there I went. This here in your eyes is be what the size of the moon would be from the Earth. What you do is you take the Earth from that distance and say 16, and then you have to reduce it by a factor of 25 again to 25% of that. So this is a quarter of this. The moon is supposed to be a quarter of the size of the Earth.
But where are you getting this from?
I'm just saying, extrapolate 238,000 miles. They say is the distance to the moon. You can only zoom out in Google Earth 39,000 miles. 39,000 divided by 238. It's a factor. If you reverse it, 238 over 39 is a factor of 16 point something. So let's say it's 16 times further away than the 39,000. Or if you bring the 39,000, it's something like this. Now you'd reduce it by a factor of over 16 instead of 100%. You go 16%. Now take that Earth, which is like about like this, which maybe looks like the moon from our Earth. And then you say, well, how small would the moon look from that distance? It would be 1/4 smaller, 1/4 the size of the Earth. So I'm telling you, the moon from our Earth looks at least that big. In my mind, I can see a lot of the moon's surface. I can see the man in the moon. I don't see something this fucking small.
I wouldn't expect to see something that small, but you're giving me all these figures, and you're telling me this is what I should see, but I disagree with you.
The distance that they try to come up with is not right. It's
No,
not.
I think your calculations of what you're trying to explain is what is not right.
Well, I did the math several times, and I've checked it. It should be fairly accurate. if you take 39,000 miles and you double it and say at 64,000 miles, you should get an Earth that looks twice the size of 39,000 miles. The distance.
I can't comment on that, but I would say that your maths is probably going to be wrong.
Anyway, you just look into it yourself. So anyway, there's a lot of other pictures. There's the best guy I could display on here would be Eric Dubay, 200 proofs that Earth is not a spinning ball. He's got a lot of information. He's got a lot of videos.
Eric Dubay, you are kidding me.
No, he's the best guy out there that can put all this stuff together and tell you.
He's a fucking idiot.
He has not been debunked yet. Everybody claims they've debunked him. They have not.
He just comes out with so much crap. It's unbelievable.
No, it's not crap.
I can't believe you're a flat earther. You are actually. You're not joking. You're actually a flat earther.
I'm not joking. I'm not joking. The moon and the sun are very close above it.
I put my what is it in the
private chat? Private chat or in the comments?
No, I put it in the comments. God, where's it gone? Oh God, I didn't put it in there.
Anyway, the scriptures tell us that the moon and the sun are two different lights. The moon gives its light from itself, not from the sun. It gives off a cooling effect, and you can actually do a temperature reading in the shade versus.
No, it doesn't. Oh Jesus, that was debunked as well years ago.
It was
right?
Never debunked.
No, of course it has. Right, if you go out, right, when you've got a moonlit night, right, you've got no clouds, right? So our coldest nights, especially this time of year, if all you've got is the moon out there, the chances are you're going to get the frost in the morning because there's no cloud cover, there's nothing to keep the heat in, so the heat dissipates, you get a cold night. So when you go outside and the moon is out and you take a thermometer, right?
Yeah.
And you put it in your garden, it will read whatever the air temperature is. If you then put it underneath, like, I don't know, a gazebo that you've got under there, and you take a temperature, it's going to be slightly warmer. Well, of course it is. You've got a gazebo over the top, which is trapping, because heat dissipates from the earth. So the heat gets trapped underneath the gazebo, so it reads a slightly different temperature. It's like if in the middle of summer, if you go out to read the sun temperature, you don't put your thermometer in direct sunlight. You put it into the shade, and that will give you an accurate air temperature. If you put it in the direct sunlight, it will be radiated heat. It will give you a false temperature. Exactly the same. If you're wanting to do the same with moonlight, you put it in the middle of the garden where there's no cover and there's nothing to hold the heat in. It's going to read cold. You then go underneath in the shade, away from the moonlight, underneath a gazebo or something like that has a canopy over it. It traps the small amount of heat that is getting dissipated from the earth. So it reads 1.5 degrees slightly warmer. That's it. You're probably going to get the odd 1 degree, 2 degrees, maybe a little bit warmer. Well, of course, if you're stood out in the open, you've probably done it yourself. If you're stood out in the open, so you're in a wide open space, you're like, oh God, it's freezing. As you're walking along and you get to the wooded area where there's a canopy, it's a little tiny bit warmer by 1 or 2 degrees because you're in the shade. It's trapping the air, the heat being dissipated from the earth. There's nothing mysterious about that. Do not show me photos of celestial objects which look like that. I've taken photos myself using a telescope of with the rings. I did it myself.
Saturn?
Saturn, yeah.
Yeah, I believe Saturn has rings. I'm not against that.
I thought you were going to tell me that there were like shimmering lights through water.
No, just say stars are not like what NASA tries to tell us.
Well, what are they?
Well, they do this kind of number. They pulse and things like that.
Well, yeah, because if you've got it out of focus and you've got the telescope going through the atmosphere, and due to heat, you've seen it yourself when you look down the road. You see the haziness on the road where it shimmers. Well, the same thing happens when you're pointing a telescope up into the sky, and then you've got an out of focus star. It will look like it's shimmering a little bit. There's nothing hard about that at all.
So this is a little bit more a footage of a star.
Yeah, the autofocus.
Anyway, this here is real-time photography. Shoot.
Flying off the spinning ball Earth is just strong enough to hold people, oceans, and the atmosphere tightly to the surface, but just weak enough to allow bugs, birds, and planes to take off with ease.
Do you not understand how that works? Can you not grasp how that works?
You're being taught when a boy.
That's how what works. I so
Right,
look at the
everything is attracted to the earth, right? So, the water, for instance, the sea, it's got a magnetic, it's not a magnetic pull, the gravitational pull on the oceans keeps the oceans down. Now he's saying there that you've got bugs, you've got birds, butterflies that can escape the force of gravity. Now, if you've got something, now how gravity works, which is why we've got weight, right? It isn't pulling the same amount of force on every single object. So if something has more mass than another thing, it will weigh more. So a bug, an insect, a butterfly weighs very little. And then around that bug, you've got atmosphere, which is the air. So we all know how, you can make a little aeroplane with your paper things and you get it to fly in the air. That's all a bug's doing. As it flaps its wings, it can escape the force of gravity. Gravity's still affecting it. It's still got an effect of gravity pulling on it, but its wings can escape the force of gravity. Now, when it comes to something like the oceans, they don't have wings. They're not trying to escape the force of gravity. So it's getting stuck to the earth. What is mysterious about that? That is dead easy to work out.
Well, think about a helium balloon or a hydrogen balloon.
So a helium balloon is like I don't know, having let's say a football, right? So you'll get a football. The football, you let go of the football, it'll fall to the ground. If you go into a swimming pool and try and push that football down, why does that football try and go to the top? Why is that? It's because when you put the football into the water, right, all that water molecule is pushing around it, and it's pushing. So it pushes the ball back up. That's exactly what happens to the helium balloon when it's in the atmosphere. All the atmosphere is getting pushed down, right? You've got the helium balloon there, so it pushes at the balloon and it goes up. That's it.
So why does it not push a lead brick? It doesn't push a lead brick up, right?
Yes, the atmosphere is pushing a lead brick up, but it's not enough to beat the forces of gravity.
Okay. Isn't it really buoyancy and density that really rule that equation?
Buoyancy, density, and gravity. You need all three. Because if you're just going for buoyancy and what was the other one?
Density.
If you're going for buoyancy and density, we all agree that the atmosphere and the oceans are less dense at the top and more dense at the bottom. So, in other words, when you're in the sea, if you're at the top of the sea, it is less dense than it is if you were to go several hundred feet down. It's going to be more dense. The same with the atmosphere. The atmosphere is more dense at the bottom. In other words, there's more pressure at the bottom than there is at the top. So, if an object basically goes to the least point of resistance, if I let go of this, there is less pressure up there than there is down there. So why doesn't it go up instead of going down? Why would it go down?
I would say it has more molecules in it than the air around it.
But there is less. There's less molecules above than there is down.
Mm-hmm.
So why doesn't it go up?
Well, it's in comparison to what the medium is in.
But the medium is less at the top than it is at the bottom. So why doesn't it go up?
Well, it's still compared to wherever it's at. As the further it goes down, it's denser.
What I'm saying to you is, why does it go down? Why does it go to the medium, which has got more molecules, and not to the medium that has got less molecules? You've got to have gravity in there. Gravity is the reason why it does it. You take gravity out of it.
What if gravity is electromagnetic?
If you take gravity out of it, right? Why does everything go down? Why doesn't it go left? Why doesn't it go right? Why doesn't it go up? Because you've got gravity. If you just go for density and buoyancy and ignore the gravity side of it, you cannot determine whether an object is going to go down, up, left, or right.
Yeah. I'd say it's an
yes.
electromagnetic force that the Earth puts on.
Right. So if
molecules.
you're going, the electromagnetic force is the reason why that things are attached to the Earth. So if something has more electromagnetic force, then it should be heavier. Yes.
Yeah.
So
Well,
all we need to do,
hydrogen is only made up of one molecule, right?
no, I don't care about that. We're talking about the electromagnetic force. So if
Compared to
something,
gold, which is 144.
if something is attracted to the Earth purely due to electromagnetic force, right? So you're saying that this glass here has a magnetic, an electromagnetic force, which is what brings it down and makes it sit on the desk, right?
Compared to hydrogen.
So
Yeah.
if I put more of a charge in this, then it should be heavier. If I earth it or reduce the electromagnetic charge that is in this, it should be lighter. But when we do that, it makes no difference.
Well, think about an egg. If you put an egg in water and you add a little bit of salt to the water, the egg will float first. You add a little bit more salt, it'll keep on going to where you can actually get it settled in the middle. It won't go up or down. You can get an egg to float right in the middle of the water if you get the
and what you've got there,
of the water.
And so what you've got there is you've got three things all involved in it, right? So that's your glass there that you put the egg in. The egg ends up sitting here. So when you put the egg in with no salt in there, it goes to the bottom because we're talking right. So let's use the three equations which work that out, which is buoyancy, density, and gravity. Right.
Yeah.
The gravitational force is what pulls the egg down, and it pulls it through the water. When you add the salt to it, that now makes the density of the water higher than it was. So because the density of the water gets higher, the egg starts to go up. The gravitational force is still pulling on the egg, which is why it doesn't shoot out the top and shoot off into space. It's still pulling on it, but doesn't have quite as much force on it. So you can get it so it'll sit in the middle. If you take the gravity side of it, then why does the egg stop in the middle? What makes the egg stop in the middle? Why doesn't it go straight to the top and keep going? Because we've already agreed that the further down you are in liquid or in air, the more pressure there is less pressure going up. So if it goes halfway up and stops there, why doesn't it go the other half? Because there's less pressure going up than there is going down, because gravity is holding it. That's where the gravitational force is stopped at that middle point.
So you've got four things there. You got actually pressure too of the column of water in there that's going against, and the further you push it down, the more that water tries to push it back up.
No, that's buoyancy.
Yeah. Well, anyway, I think we beat a dead horse on that.
You've got buoyancy, density, and gravity, and there's only the three.
Okay.
Buoyancy, density, gravity. You'll get rid of the gravity. You tell me why the egg stays halfway. Why does it stay halfway? Because if it goes further up, it's less dense, so it should go to the less dense place. It doesn't, because the gravity is holding it at that middle point. That's where it's come to rest. Exactly the same as when an aeroplane's flying. You've got thrust, drag, lift, and gravity. Right? You'll get them all in all equal. You will stay at a steady speed and at a steady altitude. If you increase the power, that will increase your speed, which will also increase the drag until they become equal. So then you will stick at that speed, and you can also use that speed to give you extra lift. At some point, you'll get to the point where you can't get any higher, you can't get any faster. Gravity.
Hey, Dave, can we display this here part about the airplane's landing?
Oh yeah, go ahead.
He's a pilot. Hold on a second here, if I can speed it up a little bit to get to that point. Let's see here. I don't know if I skipped it. Hold on a second. Sorry about this. I had it there for a second. Okay. I see it under my microscope, but there it is. Let me run this.
Philosophers and statesmen. Around this time, on December 20th, 1857, British Prime Minister Lord Palmerston wrote to the Secretary of War, Lord Panmure, stating, "There is an investigation which it would be important, and at the same time easy to make, and that is, whether the rotation of the earth on its axis has any effect on the curve of a cannonball in its flight. One should suppose that it has, and that while the cannonball is flying in the air, Impelled by the gunpowder in a straight line from the cannon's mouth, the ball would not follow the rotation of the Earth in the same manner which it would if lying at rest on the Earth's surface. If this be so, a ball fired in the meridional direction, that is to say, due south or due north, ought to deviate to the west of the object at which it was aimed, because during the time of flight, that object will have gone to the east somewhat faster than the cannonball will have done. The trial might be easily made in any place in which a free circle of a mile or more radius could be obtained, and a cannon placed in the center of that circle and fired alternately north, south, east, and west with equal charges would afford the means of ascertaining whether each shot flew the same distance.
Okay, here's the
or
part I
not.
wanted to.
Several such experiments have since been performed and shown that projectiles fired in various directions on Earth's surface always cover comparable distances with no appreciable difference whatsoever. These results are entirely against the theory of a rotating, revolving world and serve as direct empirical evidence for the stationary Earth. More evidence, similar to the cannonball experiment, is found in helicopters and airplanes. If the Earth were spinning several hundred miles per hour beneath our feet, helicopter pilots and hot air balloonists should be able to simply ascend straight up, hover, and wait for their lateral destinations to reach them.
That is a ridiculous
Such a
thing
thing
to
has
say.
never happened in the
Absolutely
history of
ridiculous.
aeronautics, however. Haughty heliocentrists must once again rely on Newton's magical atmospheric Velcro, claiming the lower atmosphere, up to an undetermined height, somewhere above the reach of helicopters, hot air balloons, and anything not built by NASA, is pulled perfectly along with the rotating Earth, rendering such experiments moot.
It's not perfect.
Granting heliocentrists their atmospheric glue supposition helps them dismiss the results of vertically fired cannonball experiments, but does not and cannot help them explain away the results of horizontal cardinally fired cannonballs. Similarly, granting them their magic Velcro helps dismiss the results of hovering helicopter and hot air balloon experiments, but does not and cannot explain away the results of airplanes flying in cardinal directions. For instance,
Yes, no.
if both the Earth and its lower atmosphere are supposedly rotating together eastwards 1,038 miles per hour at the equator, then airplane pilots would need to make an extra 1,038 mile per hour compensation acceleration when flying westwards. North and southbound pilots would by necessity have to set diagonal courses to compensate. Since no such compensations are ever necessary, except in the imaginations of astronomers, it follows that the Earth does not move. Gabrielle Henriette wrote, "If flying had been invented at the time of Copernicus, there is no doubt that he would have soon realized that his contention regarding the rotation of the Earth was wrong, on account of the relation existing between the speed of an aircraft and that of the Earth's rotation. The distance covered by an aircraft would be reduced or increased by the speed of the rotation according to whether such aircraft traveled in the same direction or against it. Thus, if the Earth rotates, as it is said, at 1,000 miles an hour, and a plane flies in the same direction at only 500 miles, it is obvious that its place of destination will be farther removed every minute. On the other hand, if flying took place in the direction opposite to that of the rotation, a distance of 1,500 miles would be covered in 1 hour, instead of 500, since the speed of the rotation is to be added to that of the plane. It could also be pointed out that such a flying speed of 1,000 miles an hour, which is supposed to be that of the Earth's rotation, has recently been achieved, so that an aircraft flying at this rate in the same direction as that of the rotation could not cover any ground at all. It would remain suspended in midair over the spot from which it took off. Since both speeds are equal, there would, in addition, be no need to fly from one place to another situated on the same latitude. The aircraft could just rise and wait for the desired country to arrive in the ordinary course of the rotation, and then land. The heliocentric theory, literally flying in the face of direct observation, experimental evidence, and common sense, maintains that the ball Earth is spinning around its axis at 1,000 miles per hour, revolving around the Sun at 67,000 miles per hour, while the entire solar system rotates around the Milky Way galaxy at 500,000 miles per hour, and the Milky Way speeds through the ever-expanding universe at over 670 million miles per hour, yet no one in history has ever felt a thing. We can feel the slightest breeze on a summer's day, but never one iota of air displacement from these incredible speeds. Heliocentrists claim with a straight face that their ball Earth spins at a constant velocity, dragging the atmosphere in such a manner as to perfectly cancel all centrifugal, gravitational, and inertial forces, so we do not feel the tiniest bit of motion, perturbation, wind, or air resistance. Such backpedaling, damage control, reverse engineered explanations certainly stretch the limits of credibility and the imagination, leaving much to be desired by discerning minds. David Wardlaw Scott wrote, "Dear reader, do you feel the motion? I trow not, for if you did, you would not so quietly be reading my book. I doubt not you have been, like myself, on a railway platform when an express train rushed wildly past at the rate of 65 miles per hour, when the concussion of the air almost knocked you down. But how much more terrible would be the shock of the Earth's calculated motion 1,000 times faster than the speed."
All right. There's a lot to digest there. And if you
No,
want to
there
talk
isn't actually. That just absolutely showed. And this is why I say about Eric Debay. It doesn't have a clue what he's talking about. All he's done there is shown to anybody who has the very basic fundamental knowledge of flight of how much he actually doesn't know. Every single thing he said there was wrong. Everything he said was wrong. So you can laugh all you want. I don't know why you listen to these people and then don't actually try and find the answer to the questions that is.
Oh no, I've researched this for 7 years, man.
No, you haven't. What you've done is you've listened to people like Eric Debay. That's what you've listened to. You listen to their sound bites all the time. His ignorance on flight is absolutely breathtaking. It really is breathtaking. So his argument there is that when you're on if the Earth is traveling, you're on the equator, it's traveling at 1,040 miles an hour. You get into an helicopter, you hover with the helicopter there, the Earth rotates underneath the helicopter, and you end up in your destination. What an absolutely stupid thing to say. That's like me saying that when I'm on a train traveling at 100 miles an hour, if I want to go to the back of the carriage, I don't need to walk to the back of the carriage. All I've got to do is stand at the front, jump, and I'm going to end up at the back of the carriage going at 100 miles an hour. That's exactly what he's saying.
No, you're in a controlled atmosphere if you're inside a carriage.
And what do you think the Earth is? Like I say there, when you walk outside,
you're in a complete vacuum.
When you walk outside, let me finish talking. When you walk outside, you don't end up with 1,000 miles an hour wind hitting you against you, because the air, just the same as it is in a train carriage, is traveling with the Earth. So in the train carriage, the air in the carriage is traveling with the carriage. The air on the Earth is traveling with the Earth. So it's going round. As the Earth rotates, so does the air that's attached to the Earth. So when you walk outside, you don't get 1,000 mile an hour wind. When you take off in a helicopter, you're traveling in that air pocket when it goes. Do you believe that you can fly an aeroplane backwards?
Maybe a modern one. I don't know about the old ones. Of course not.
Any aeroplane, fly it backwards.
Well, the new ones maybe have propellers that can go backwards. I don't know.
No, I'm not on about that. I'm talking about a normal a glider. It's got no power. Can I fly a glider backwards?
I don't think so. No, of course not.
I have flown a glider backwards.
Okay.
Do you know what a Cessna 150 is?
It's a very small. Just a single prop on either wing.
Yep. Can I fly that backwards?
I have never seen anybody do that.
Google it.
Okay. Well, I trust you. If you
do it now. You've seen this in here. Google. I don't know. Cessna 150 flying backwards. And yes, I haven't done it with a Cessna 150, so I've done it with a glider. I've flown a glider backwards. Right. What?
130, 140.
Okay, and now we fly into the wind.
We're full power,
Yep.
reaching up. Flaps are up. Right on power on stall.
10,
There.
9,
Good till we hear the
8.
horn.
7.
6. Good till we hear the horn.
I hear
I
it.
hear the horn.
2, 1.
2. There's the horn.
Oh my god, get it off. I don't like it.
That is what we do stall.
We're just stalling?
Not yet. You'll know.
I don't like it.
That's just
I'm not a big stall girl. Turn it down.
good flight.
All right, we did it.
0.0 indicated on the ground speed.
I panicked. It was really fun.
Right. So how that's working? So how that's let me explain it to you. How that's working there is when an aeroplane's flying, it doesn't care what the Earth is doing. It cares the wind that it's traveling for what it's doing.
Sure.
So it does work much easier with a glider because you can fly a glider at much slower speeds. One of the gliders I used to fly, its stalling speed was about 25 knots. Right. So its stalling speed was 25 knots. So if the wind that I'm flying into is hitting me at 30, 35 knots, and I lift the aeroplane so I get slower, slower, and slower, my airspeed indicator will say that I am traveling at 25 knots. My ground speed will show me going backwards at 5 knots. So what he did there with that aeroplane, what he does is he gets it right at the stalling point, to the point where it's just about to stall. So he wants to get as slow as he possibly can. He then puts it into a headwind, and if that headwind is greater than what his stalling speed is, he will go backwards. So anybody on the ground looking up will go, that aeroplane's going backwards.
Yeah.
When they look down at the ground, that ground will look like it's going backwards, and that's exactly how it works on the atmosphere. So when an aeroplane takes off, an helicopter takes off, it is flying in that pocket of air, which is surrounded by the that surrounds the Earth, right? So if that atmosphere is traveling with the Earth, that aeroplane is traveling with the Earth. So if it's traveling east to west, I've forgotten which way it goes. The Earth rotates west to east.
Yeah, west east.
So if he's traveling from the equator, you've got the airspace. Sorry, you've got the Earth's rotation at 1,040 miles an hour, and then you've got his aeroplane is traveling at 500 miles an hour. So technically, he's traveling at 1,500 miles an hour in that direction, right? But the air is traveling with the Earth, so the Earth's rotation is absolutely irrelevant. The same as if he turns around and goes the other way, he's traveling at he's traveling at 500 miles an hour, but the Earth is rotating at 1,000 miles an hour going in the opposite direction. It makes no difference because the atmosphere is stuck with it. So whether he goes east, west, north, south, makes no difference. Now, where he was talking there, whereas if you're from the equator, which is traveling at 1,040 miles an hour, where I am at the moment, which is about 54 degrees north, it's probably traveling at 600 miles. Probably about 600 miles an hour. So there's a 400 mile an hour difference. So if I was to suddenly travel from the equator up to here, there's a 400 miles, at least a 400 mile an hour difference. If you were to do that extremely fast, then I would overshoot where I'm going, because I'd still be traveling at 1,000 miles an hour east to west, or whichever way it goes, going north. So that I would overshoot the place that I'm going. But when you're flying an aeroplane, the distance is the speed that you're traveling is very, very small. So the amount of corrections you will need to do for what we call the Coriolis effect is minuscule. Then it makes no difference. A pilot is constantly making corrections. Just like you do when you're riding a bike or driving a car, you're constantly making corrections with the steering wheel. You're constantly making corrections on the bike. That's exactly what you're doing when you're flying an aeroplane. And that compensates for it. It's not something that happens over literally, 30 seconds. If you're traveling from the equator to here, especially if you're in a light aircraft, it's going to take you, to fly from the equator to here in a light aircraft, it's going to take you 7 or 8 hours. If you're doing it in a modern aircraft traveling at 500 miles an hour from the equator up to here, it's going to be at least a two-hour flight.
Now, in 7 hours, how far does the Earth spin? If it spins 1,038 miles per hour from at the equator, in 7 hours, the Earth should have spun 7,000 miles.
Yeah.
Now, in seven hours, are you going to overcome that 7,000 miles flying up towards the equator from, let's say, San Diego
Yeah, because you've already got you've heard of conservation of momentum, haven't you? So something that's at rest will stay in rest unless it's affected upon. Something that's travelling will stay travelling unless it's affected on by something. So it won't make no difference to it because the atmosphere is moving with it. Why would it make any difference?
There's you're talking about Saturn.
Yeah.
Now, is that real or is that CGI?
I've got no idea. That could be CGI. It could be real. I've no idea.
Yeah.
I wouldn't know.
Anyway, this is a movie called The Deep Field, The Impossible Magnitude of Our Universe. Of course, they claim that the sun looks like this, which I'm saying is bullshit.
Yeah,
And-
but that isn't how it would look with the naked eye. That's how it's looked with like solar filters. Yeah. So you can actually see it. Yeah. So I don't see any problem with that.
Sure. So they take videos of like this,
Yeah,
and zoom in, and you see all these stars off to the side, things like that.
Yeah.
They zoom in various ways, and they make it look like you're flying through space.
Yeah.
And then there's other places where it looks like you're going actually sideways through space. I don't know if I can find where it is. This here is a neat thing. Now you can say this is real. It's real people, but it made up the back end of a spaceship. So they did that with CGI.
Yeah, but them pictures of the galaxies and going through space, they're just a representation so that you can actually, have an idea of what space looks like.
So is this here that we're watching right now a representation, or is it real?
I don't know.
I'm telling you, this is bullshit.
Yeah, but I don't know why you're saying it's bullshit.
Watch what they did here with these people. Okay, they took a mirage of people. Millions of people, and they faded into something. So part of that was real. Here's another part that's a whole bunch of people. And then they faded into the scenery. So they can do all kinds of shit.
Yeah, but that doesn't look very good, does it? It's not very.
Yeah.
Not
very professional.
Yeah.
Well, by the time they faded in, it just shows that they go back and forth between different things and fade in and out. And of course, I'm speeding this up. If you had normal speed, it would look a lot more seamless. But
that was the photo I took of Saturn. It's not a very good one. It's not really in focus.
Okay.
That's the photo I took.
Okay.
And I did that through the telescope that I had, and then got the iPhone and tried to get it there and to take a photo. And of course, I couldn't get it in focus.
I forget where I saw the Saturn. Okay, here's Saturn rings here. Compare your screen. Yeah, as a comparison, what maybe in real life of what you saw in the telescope, and then what they show.
Yeah, but actually, through the telescope, it looked far better than this. I couldn't get the camera to focus properly on it. When you look through it, it looked absolutely brilliant. And I thought, I've got to get a photo of that. But of course, because the Earth is rotating, it's constantly moving across the thing. You're constantly having to alter. When I was getting people to look at it, I was like, quick, have a look. So I get it. So it was like the furthest away from, on the furthest edge here, because I knew it was going to move that way. And I get it there, and I'm like, quick, come and have a look. And then they'll have a look, and then it go across, and they go, right, I've gone. And then I have to try and twist and get back onto it again, due to the rotation of the Earth and the distance I'm looking.
Now, another good thing to think about is the equinox, the summer equinox.
You don't seem to listen to what I'm saying to you. You've just got your sound bites. You just keep going. You don't actually engage into a conversation. You just go on to the next one once I speak to you.
I tend to move a little fast.
You don't actually engage in what I'm actually telling you.
We're not going to agree, Paul. And I'm just presenting my side. You're presenting your side.
You're not even going to address what I'm saying. I'm addressing everything you're saying. You're addressing nothing that
You're
I'm
saying you're debunking me, but I'm saying you're not. It's from your perspective or from science perspective. Now, I wanted to present this and get you to think about the summer equinox. And summer equinox, June 21st, on some places on the earth, there's 17 fucking hours of sunlight. In some places, most places in northern hemisphere is 15 hours. Now, sunshine shining on that globe right there is going to give you about 12 hours from equal side all the way around to the other side. Where do you get 17 hours from? You have to add 2.5 hours on either side to get 17 hours. Now, the tilt of the earth is not going to get you an extra 2.5 hours of sunlight both sides. I'm sorry. Especially if you're on just a little teeny portion of that surface. As soon as you get out of that and you see mountains on either side of you, you're not going to see down around the curve. So even that little plane that you're sitting in, you're going to see a little portion of sunlight, but all the way back here and plus 2.5 hours, no way. You got from 17 hours to 24 is what? That's 9 hours left. No, that's less than that. That's 7 more hours for the nighttime to occur.
You already know what the answer is, and you already know what the answer that I was going to give you is due to the tilt of the
Go
Earth.
ahead.
And absolutely, that is why you get the extra hours. That's why in our summer in the northern hemisphere, the Earth is tilted towards the sun. So you get the extra hours, and it also puts the North Pole into probably almost 24 hours of sunlight. And the same in the southern hemisphere. In their summer, the Antarctic is in during the middle of their summer.
Okay,
it will be in constant sunlight. So yes, you would get that.
This is just for the guys in the chat.
You know the answer, but you basically just dismissed it straight away because you said it's not due to
this video. Why are they not showing?
This is just for the guys in the chat room. Ave Maria.
In this video, though, Paul, why do they not show the tilt as 23.4 degrees? They show maybe 5 degrees of tilt here, but it ain't no fucking 23.4 according to where the sun is on this video.
Yeah, but why do you think it should show the tilt?
Well, because if it's 23.4 degrees, you should see the side toward the sun. It should be spinning at a tilt.
They're just taking a picture of the Earth. They're not trying to show the tilt or whatever. It's just a picture of the Earth.
Yeah. You know that they've never taken a picture from outer space. They've had to piece stuff together. The artist says he had to piece it together.
No, they haven't. What about the 1972 Blue Marble? That there was no CGI available then. There was no Photoshop available in 1972.
Now, how are they filming this?
You don't address anything I tell you. You just go on to the next thing. Right. So in 1972, it was taken with the Hasselblad camera, right? Which is the original Blue Marble taken in 1972. And if you go to NASA, the what they call it, the negatives are actually available there to actually see. Address that. So don't show me a picture of the Blue Marble that we have now that was taken, which was composited together by that bloke who was just a representation of what the Earth looks like about 5 years ago. Address the 1972 original Blue Marble.
This area here is a composite. And
so what's wrong with the composite picture? Because all a composite is, you can get a camera and you can take a panoramic view. So you'll get your camera, you go around like that, and you'll get a panoramic view. Is that picture fake? It's a composite.
No, but what they said is they took slices of satellite images and then they pieced it together to get the Blue Marble.
There's a composite because the satellites weren't close enough to take. The satellite that it was done from wasn't close enough to take. It wasn't far enough away to take a full picture of the Earth. So as it's rotating the Earth, it's taking composites of pictures, and then they all get pieced together to make a picture of the globe.
Mm-hmm.
What's wrong with that? You're not even
nothing-
going to go on to the next. You're just going to go on to the next point, aren't you?
Well, I like to cover a lot of ground.
Yeah, but you don't discuss what I'm telling you.
Oh, why did they not say that this here is fake or that it's a fisheye lens?
Well, again, that's wrong to say that it's fake. It's not fake. It's just taken from a fisheye lens. They use a fisheye lens because you get a wider angle of view, so you can get a better picture of what you're looking at. They were interested in what flat earthers believe. They were interested in debunking flat Earth. They couldn't care less about flat Earth. So they were there to show the guy jumping out of the Red Bull balloon. That was it.
So if you float down the Suez Canal,
So we now
you
moved on
should be
to
able to see a little bit of dipping down. But
Why
if
would
you
Why would
you
you?
do a time lapse, it pretty much looks flat the whole way.
Do you know how big the Earth is?
It's supposed to dip 66 feet every 10 miles. You should be able to see.
So how long does it take that ship to what's it traveling at? What speed is that ship traveling at? And how long does it take to cover? So how long does it take to cover 10 miles?
Well, it's of course they're speeding this up, and I'm going to speed it up even more just to give you a good view.
So a point is, right, at its normal speed, what speed is it traveling at? I don't know, 20 knots. Most
5
ships
miles an hour, maybe. Yeah.
Right, so 5 miles an hour. So it's 5 miles an hour. Now I think they're going a bit faster than that, but whatever. If it's traveling at 5 miles an hour, that means it would take 2 hours to cover a distance of 10 miles. And like I've just told you, go take a experience flight in a Cessna 150, 172, or a PA-28 or something like that, and then you see if you can notice the distance or the elevation and descent over 30 seconds. You won't. But then look at the altitude meter and you will have risen and fallen several hundred feet and you'll not feel it. Over 30 seconds. And you're telling me that I should see the dip of a boat traveling at 5 knots over a 10-mile distance, which is 2 hours? How the hell are you going to notice that over 2 hours? I don't think they travel at 5 miles. I don't think they travel at 5 miles an hour. I think they travel at a bit faster, probably 20 knots, 15, 20 miles an hour. I don't know. But it's still half an hour to cover 10 miles.
Mm-hmm.
And what's the drop over 10 miles?
Oh, 10 miles is 66.6 feet.
You are not going to notice 66 feet over 10 miles.
Well, if you look up in the air,
Seriously, go in an aeroplane, take control of it, right?
Yeah.
Seriously, and you will struggle to keep it at 2,000 feet. I'm serious. You will. If he leaves you to it, the pilot leaves you. You will raise 200-300 feet, and you will do it in minutes. And you're talking 66 feet over an hour.
Yeah.
You're never going to notice that. You're never going to notice it.
Right. But now look up.
You're not listening to me. You're just going on to the next one, aren't you?
Well, look up in the air and look at a chemtrail over your head. You should see 10 miles in the air. And a lot of times I see a chemtrail going from one side of the sky to the other.
They're contrails. They're not chemtrails.
Okay. Be that as
they are condensation trails, not chemical trails.
Well, somebody's spraying something.
No,
anyway,
it's condensation.
Anyway, from one side to the other, in 10 miles, you should see 66 feet of drop. Those trails.
How are you going to see? You expect me to be able to look out at a distance of 10 miles and see 66?
You should see a slight curve.
Feet over 10 miles.
You should see it.
I've already explained this one to you. Right. If you look at the average light column on the street, it'll be about 30 foot. So have 2 of them out on it. You imagine looking at that over 10 miles. You'll not see it. You'll not see it.
Yeah, you should be able to see a little bit of curve. I'm telling you should be able to. Anyway, I'm telling you, penguins don't live on Antarctica. They don't live up on the ice wall.
No, you've got penguins. There's penguins that live in Australia. There's penguins that live in I believe there's penguins in Argentina. I believe there's penguins definitely in the Falklands.
But basically, they don't live up on the ice shelf, which is about 100 feet tall at least. And Admiral Byrd shows this when he goes down.
Oh God! No, don't go on about Admiral Byrd. His diaries were debunked years ago.
What was debunked about him?
The diary about when he was flying along and he went.
No, I'm talking about his videos. You can fucking see the ice barrier in it. He even tells it. It says, and now we come to this natural phenomena called the ice barrier. Even shows it in his videos.
Yeah, there's a big wall of ice.
You got this, Numi. I'm all liquored up. I gotta go lay down.
I know, right? I put me. What is it? Let me just take a copy of that. Copy. I go into the private chat. I'll put it in. How do I put it in there?
Numi's in charge.
Paste. Right. I put the link to my channel in the private chat, and I'm also going to put my email address in, because me and you need to have a conversation where it's not just literally on the fly like this is.
Okay, let me copy that. I'm going to open that in a new thing, and I'll put a shortcut to it. Paul Camish. Okay, I'll subscribe. Got it.
Yeah, and I'm putting me email address in as well, so you can email me.
Okay, let me get that there. Yeah, copy the link address.
Yeah, me and you will have to have a conversation about flat Earth.
You've been a good challenge to me.
But you haven't addressed anything. I've said all into the source. I've said something to you. You've gone on to the next one, the next one, the next one.
Yeah, well, I don't like.
Do not start on corpuscular rays, please.
There's so much to cover. If we just stay on one topic, then people don't tend to believe.
Yeah, but you won't stay on one topic. You'll just go from one to the other. Corpuscular
I like to move quickly from one to the other because there's a lot of ground to cover.
No, but you don't address the points that I bring up. When I bring up the points, you just go, yeah, okay, and then you go on to the next one. You don't address the points. You just keep going over to the next one, the next one, the next one. It's almost like you're ignoring me and just going to the next.
But I have a different explanation for all those things than you do. So, yeah, here's the thing about the sun's rays coming in, and supposedly the tilt, takes into account all that.
Yeah, but that didn't show the tilt. That showed the sun rays coming in parallel with it. Where if there was a slight tilt, so the whether it was north or south, the southern hemisphere would get more sun, or the northern hemisphere would get more sun, depending on which way it's tilted.
Now, would you agree with this picture here? It says the Earth makes a full rotation every 24 hours, therefore it would face the same direction at 12 p.m. Midday, no matter where it is in its revolution around the sun. Now, I don't know if that's exactly the truth, because they say there's a sidereal year and there's a actual year. So it says, do you see a problem here? The dark side of the Earth over here pointing towards these set of stars. Half a year later, over this way, the dark side would be here over towards these set of stars. You would see a total different set of stars at nighttime. Now, if it makes one rotation every 12 hours or 24 hours, shouldn't the tilt always be that same direction, right? It always maintains direction in the same, so that you get winter here, you get summer here. Or vice versa. It says after 6 months, day would be night and night would be day. But we do not observe this. Therefore, it is impossible for the Earth to revolve around the sun. Yeah, can you see any holes in that?
Yeah, I see a problem. I see a problem with that. What I would do is I would actually, instead of googling what the flat Earth answer is, I would Google what the scientific answer is. What you've got there is you've got the flat Earth answer. You haven't got the. I mean, I've got no idea. I can't comment. I mean, you really are dropping me right on the. I've got no chance of. I'm no expert. I don't claim to be an expert.
Yeah, I'm just dropping a lot of different things in here. I know it's. Another thing is, why can you see the blue through the moon during the day, and you see the black of the in through the moon in night in the section that's not lit up?
Sorry, ask that question again. How can I see the blue through the moon?
I had a picture there. It showed the moon in the middle of the day. I can't even see if I can find it again. I don't know. I skipped it over too quickly. This video here has just got a ton of
Right,
stuff.
I think I know what you mean. So sort of like an half moon during the day.
Right. Yeah, and you can see sometimes you can see stars through that moon, like as if it's plasma.
Stars through the moon.
Yeah, they have pictures where they actually show a star shown through the blue part of the moon. I don't have a copy of that, but I've seen.
I've never seen that. And how can we confirm that it's actually a star or whether it's
somebody's going to have to show
or
that. I don't know.
Yeah, I won't be able to confirm whether it's a star or whether it's just like I don't know, a little bit of dust
anyway,
on the lens.
If you look at the moon at night, you'll see black section here, and in the daytime you'll see blue. As if the whole surrounding blue also shines through that section of the moon.
Well, no, because the moon is outside of the Earth's atmosphere, and it's the Earth's atmosphere reflecting the light, the wavelength. When the light hits the atmosphere, it's a longer wavelength, I think it is, which then gives you a blue image. That's why the sky looks blue. It's due to the basically the light scattering.
Mm-hmm.
So basically the atmosphere appears blue, and obviously the moon shines through the atmosphere. So the part of the moon which is in shadow will look to be blue because you're just looking at the atmosphere.
Okay.
And on a night, because the sun's not shining on the atmosphere, it then becomes clear. And when you're looking up into the sky, it's black. So the bit of the moon that's not being illuminated is going to be black. I don't know. That's not difficult to understand.
Well, I think a lot of these things can be understood both ways.
Do you agree with my explanation, or do you have?
I can kind of see that. I'm just saying, a lot of these things can go both ways. It can go flat Earth or globe, and a lot of that.
No, I don't know how it can go globe. I don't know what the globe argument is for
that. Interpretation.
I don't know what the globe argument is for that, because all you did is you asked me a question of why do I see blue through
everybody believes that you can land on a moon. And I'm telling you can't. I think it's plasma or it's something else. It's not quite a solid sphere.
And what evidence do you have for that?
Well, first of all, 260 degrees Fahrenheit on the side towards the sun. There's little astronauts up there in a spacesuit, and they're going to be in hotter than steam temperatures. Why in the world would they even subject themselves to that for 2 fucking hours?
You do understand they've got a spacesuit on which would have been designed at the time to protect them from that. I don't think they were in the full sun part though, were they? I have heard this. They were in the full sun part.
I thought they landed on the side towards the sun.
Towards the sun, yeah, but not the full sun side. So it wasn't like landing on Earth and landing on the equator. It's probably equivalent to them landing in the northern hemisphere, which obviously is cooler due to what it was. And then the suit that they have had pipes going through it, which either pumped warm water or cold water, depending on where they were. I'm sure that if you Google how did the astronauts cope with the temperatures of the moon, it will tell you. But what you'll do is you'll just listen to what the flat Earth argument is and not bother looking. But you've asked that question. Have you ever Googled to try and find the answer?
I probably have a little bit.
What's the answer?
Spent a lot of time on that, but yeah, they're always going to come up with.
I don't think you will have spent a lot. It sounds like you haven't spent a lot of time looking at any of these answers. All you've done is listen to the flat Earth answers. You don't have an answer for it to yourself. You've taken the flat Earth answer and you've just run with that. Because everything that I've said to you, you've not. All you've done is gone to the next argument. It's like I'm talking to myself.
Oh, okay. Oh, another thing is they say that the moon is tidally locked to the Earth. You know that, right?
Yes.
We always see the one side of the moon. We never see the dark side of the moon.
That's right.
Agree.
Yeah. Yes.
Okay. So how did that happen? Supposedly because of gravity holding the moon. Finally, after billions of years or millions of years, it got to where it did not spin in reference to the Earth anymore, right?
Well, no, it's still spinning, but it's spinning in the same amount as it rotates.
Every 28 days, it spins one time. It's exactly one time in 28 days.
Yeah.
What's
No,
causing
it's
that?
not. It's not exactly. No, that's why there's a wobble to the moon. When if you actually
Little bit of
do
wobble.
it,
Yeah, but
you will get a
never-
wobble to it.
you never see it go to where you see a
No, you won't. You
different
won't see the
section
dark
of it.
side. No, you won't
Right.
see the dark side. No.
Now, if you know anything about the sun and the distance to the earth, and then the moon and the distance to the earth, and the gravitational force, what they say on the internet,
93 million miles to the sun and 240-ish thousand miles to the moon. Thereabouts.
right? Now, the gravitational force, you can look it up on
Yeah.
Wikipedia, different places. It'll say that the
Yeah.
sun's gravitational force is a factor of 3.67 times 10 to the 22nd power newtons of
Yeah.
force.
Yeah.
Gravitational force. Gravitational force is G times the mass squared, the mass and the other mass multiplied by each other divided by the distance squared. So 93 million miles sounds like a far distance compared to the moon, but the mass supposedly is so fucking bigger that it makes the bigger difference, and says that the sun's pull on the earth is 777 times stronger than what the moon is on the earth. The moon is a factor of 10 times the 20th, not 10 times the 22nd. And it's like 1.96 or something like that. If you do the math, you get about a factor of 170 something, 177, I think, if I remember right. So the sun force on both the earth and the moon should have been such that both the earth in that amount of time should have been tightly locked to the sun. The moon should have also been tightly locked to the sun, because the sun is that much more powerful. And yet we find that somehow the moon gets tightly locked to the earth. It doesn't make sense. And what causes the tides? If the sun is 177 times stronger, then the tides ought to be caused by the sun, not by the earth.
Yeah, it might be 170 times stronger, but it's also 400 and odd times further away than what the
It takes into account the mass of the sun.
Yeah, well, I mean, I've never done the maths of it, and I don't have the intelligence to work out the maths. So all I can do is go by what you're telling me. That means nothing to me.
Yeah, I've done the math, and you look it up on the internet, and you'll see that they actually tell you that.
I'm not confident that your maths is going to be accurate enough to work this out. I'll listen to a scientist on this. You are not going to tell me about why the rockets, when they take off the curve. You know the answer to this. I know you do.
The firmament, yeah.
No, it's not the firmament. Right. When a rocket, right, the most efficient way to send an object into space would be to go straight up. Right.
Yeah. And why don't they?
Why don't they? Because it's the most inefficient way. It's so inefficient. It's so inefficient to do that. So what they do is when it goes up, and then it starts to curve, right? So you know how that works, don't you? To get into an orbit. So it gets into an orbit around the Earth, right? So if these are satellites, they want to get them into orbit anyway. So that's what they need to do. They need to get them into orbit. So they need to go around the Earth. They don't need to go straight up and then go around the Earth. They go up and then start the curvature and start to curve around the Earth.
Mm-hmm.
Just Google it. Seriously, Google why the rockets, when they take off,
why can't they just keep on going straight up, Paul? Why can't they overcome gravity?
It's so inefficient to do that.
Why? You're already overcoming gravity starting up.
No, they're trying to get into an orbit. The idea is to orbit the Earth, right? So why would they go straight up? Because they're not in an orbit if they go straight up. To get into an orbit.
Why do they even need to be in a fucking orbit? Why?
You know what the definition of a satellite is?
Yeah, but satellites do not exist. There's 17,000 of them up there. If there were, then why in the world can't I get a signal over in West Virginia going through the mountains? Cell phone signal. A cell phone signal.
Cell phone signals don't come from satellites.
Well, what's the purpose of the satellite then? Why do they need 17,000 of them?
Every satellite that's up there has individual jobs that it's doing. There's amateur radio satellites up there, which has got nothing to do with cell phones or getting a signal on your mobile phone or whatever. That's to do with
You
amateur
need-
radio. And
You
you've got other
need
stuff.
17,000
You've
of
got,
them
other,
up there.
you've got other satellites which are to do with weather, so they're not taking photos. They're not sending signals down to mobile phones. They are just monitoring the weather. So it depends on what job the satellite has been given when it gets sent up there. But if you think that you'll get a mobile signal on your mobile phone from a satellite, you are absolutely deluded. Nobody, unless you've got a satellite.
Why in the world do we need Starlink then?
Starlink is internet. It's not mobile phones.
Well, it's still a signal.
Yes, a different signal to a mobile phone
Why can't we use that for cell phones then?
because it's not a cell phone signal. It is an internet signal.
Signal is a signal. I mean, they could use it for multi purposes. And
I've got a piece of equipment here that does a signal, right?
Yeah.
I can't talk on a mobile phone on it, but why not? Because it's still a signal.
Yeah. Uses a frequency going somewhere.
Yeah.
Now is that a ham radio?
Yeah.
Okay. Hey, why do all the satellite dishes tend to point down towards the equator? Why do all the satellites need to be in orbit down around Mexico and not up around New York City? Why can't we point our satellite dishes straight up?
I've no idea. I'm not into why.
Look at
how
all the
satellites
satellite
work.
dishes one time. They're pretty much all point towards her horizon. They're picking up a signal from a cell phone tower somewhere, or they're bouncing the signal off the ionosphere to something that's over 15, 20, 25 miles away. They're bouncing signals off of ships that are out on the ocean from
So the
various
ships out. So you're telling me the ships out on the ocean that we're sending we're pointing our satellite dishes at.
No,
so
they've got a lot of little repeaters out there on the ocean and different ships that are out there. So you can get a signal going a good distance around the Earth.
So
but a lot of our communication is done through the cables laid down in the ocean. Majority of our signals going around the Earth are going through the cables that are laid down in the ocean.
So you're telling me that my satellite dish is pointing towards a ship or something out in the ocean?
If there's something down in the ocean area and it's trying to point towards something, it's not going to point straight up towards the satellite overhead. It's going to point towards the horizon area where it's going to pick up a signal off the ionosphere. The ionosphere is powerful enough to bounce signals around.
Right. But you do realize that the ionosphere alters throughout the day, don't you? I mean, obviously, with me using amateur radio, the ionosphere becomes, like I say, it becomes ionized, but it's not a stable signal.
Mm-hmm.
So, like this time of day, I will be getting a different areas than I am at dinner time tomorrow, and then sometimes I can pick nothing up at all. But yet my satellite dish, that seems to work all the time, but it's still working on the same principle.
Yeah, I just don't see a lot of satellite dishes pointing straight up. And why can't they put all these 17,000 satellites at various locations around the Earth? Why do they have to all be around the equator? They say they have to be in a geosynchronous orbit. Like, why the fuck?
Yeah, because they need the satellite to move with the Earth. So as the Earth rotates, they want the satellite to stay. So
I'm telling you, it's all a deception. If there was that many satellites up there, aren't they reflective? If they're that reflective, all the light shining off the sun should speckle off of those satellites, and we should have no nighttime here on Earth.
No nighttime.
Yeah, that'd be too much
Have you ever been out on a night? I mean, just do it this next weekend. Go out on a clear night. Obviously, it needs to be a clear night. And sit and observe the sky, and you will see satellites all the time.
Oh yeah,
you can see hundreds a night.
I've seen something that looks like Starlink going over top.
You could, yeah. Well, what's your answer to that? Oh, well, I've spoken on the.
I saw these orbs. I saw these orbs go over from a distance, and they came up almost straight above my head, and then they disappeared. They didn't keep going across the whole sky. I'm telling you, it's probably some kind of a hologram.
You do know why it disappears, don't you? So, for argument's sake, especially here, if I'm stood here and the International Space Station starts to come over from here, It looks really bright as it starts to come over. Once it starts to get overhead, it gets fainter and fainter and fainter and starts to disappear. And the reason it does that is because the sun is over there.
Okay.
And basically what happens is, as that goes over and goes further and further and further east, it gets into the shadow of the sun, so it disappears.
I was doing this at 8 or 9 o'clock at night, looking up in the sky, and I didn't see any sunlight nowhere at all.
No, you don't
And
see
yet
the
these things disappeared almost right above my head.
Yeah, because the sun is shining off the satellite. You can't see the sun. The sun is reflecting off the satellite. So as it gets above your head, it now becomes into the shadow of the Earth. So it slowly fades. If you watch them, they get dimmer and dimmer and dimmer, and until they disappear. That's because it's going into the shadow of the Earth.
So Starlink is not following the same pattern as the rest of these guys. They are traveling across the sky where you can see them visibly. And why would they not be doing the same thing as what the normal geocentric satellites do, where they look like they're stationary above the Earth if you would see them? They're so far away you can't see them.
Because satellites have different jobs that they need to be doing. So it all depends on what the job and what they want in that particular satellite to do. So some satellites are not geostationary; they're not. They actually orbit the Earth. Some of them are geostationary, especially like weather satellites and stuff like that. I think that they're geostationary.
Okay, so what can track them and get a signal from them? What's the purpose of them if they're traveling? What can keep track of them and keep the signal on them?
It depends on what the job is.
Yeah. But
Right, so
a normal satellite dish sitting in your backyard has got to stay stationary on a satellite, right?
So that would be a geostationary satellite, I presume. I'm no expert. I'm just presuming it's going to be a geostationary one. So it's picking up the signal all the time. So where would be the best place to put a geostationary satellite? Where would be more efficient? Just think about it in your mind.
It shouldn't matter what kind of orbit you go around the Earth. If the Earth is spinning and it's traveling through space at 66,600 miles around the sun.
I would have just assumed, just thinking about it myself, I would assume that it would make more sense for a geostationary satellite to go around the equator. So as the Earth turns, it stays with it.
Okay, then why in the fuck do we need 17,000 of them? You should only need maybe 20. 20 of them.
17,000 what?
Satellites that have been put up in space.
Yeah, but are them 17,000?
The number that they quote is a lot.
So are them 17,000 all to give you Sky TV?
No, but why do they need that many?
So it depends what job they're doing, right? So Starlink is putting a load of satellites up there, which I think is a waste of fucking time. I think it's complete. It's going to fall apart. That, but anyway, so Starlink's putting a load of satellites up there, which is to give places internet access where it's not normally available, right? So they're up there for that reason. You've got weather satellites up there, which are there to monitor the weather and give us our weather reports. So you want more than one up there. You want several of them up there. You've then got your GPS satellites. So you've got the United States GPS satellites. You've got the Russian satellites, and they've got the European Union satellites. There's the three systems available now. America started it first, then Russia kicked off, and then the EU satellites one. So it depends on what system your phone device is using. So there's all them satellites up there as well. Right. Then there's all the different cable TVs or whatever they're called, satellite television and whatever. So there's them up there as well. And there's other ones up there doing different jobs. I don't know. So we've got thousands up there.
Yeah, I hear you, but I don't believe it. I'm just telling you. To me, I've looked at all these satellites, and it seems like they're all pointed towards the horizon somewhere, and they're picking up a cell phone signal. Some of them are pointed towards the north, some towards the south.
Right. Satellites have got nothing to do with cell phone signals. Cell phone signals are done by cell towers in your local area.
Yeah.
Nothing to do with satellites.
Well, you can
get satellite phones, right? And they cost you a fortune. Good luck with getting one of them. It will cost you an absolute arm and a leg to make a phone call. You can get satellite phones. A lot of military use satellite phones, but the general public use normal cell phones, which connects to a tower in your local area, not satellites.
Well, it seemed like they're spending a lot of money sending these satellites up. Why don't they cater to the people in the mountains that need good internet and good cell phone signal back in?
Right. Again, satellites have got nothing to do with cell phone signals. So you might have people living up in the mountains and they can't get a cell phone signal. They need a cell phone tower installing, not a bloody satellite. Because satellites are not doing cell phones.
Well,
right? Starlink is already available. If they want to subscribe to Starlink, they will be able to get a signal on the phone to get the internet.
Just seemed like there's a lot of deception going on, especially like on 9/11.
No, it seems to me like you're not addressing any single topic that I bring up. You're basically just
trying to move quickly from one thing to the other so people can see that there's a wide variety of things that you need to look at if you're going to.
No, what you've got is you've got loads and loads of sound bites that you keep spilling out, but you're not actually addressing anything that I'm telling you.
Paul, a lot of these things can be taken either way. They can be taken towards the globe or towards flat Earth. But you got to do the research yourself, and a lot of people are not even open to researching themselves. The ice wall surrounding the nation, the continents, is even depicted on the United Nations flag. They have a flat Earth map on their flag, and they show a fig trees around a fig leaf all the way around the outside edge. That's depicting the ice wall, and they fucking know it. And they just don't want us to know. They wanted to keep us in a matrix. They want to keep us in a control system. Why did three buildings come down on 911? Why did 3 buildings come down on 911? Why did Building 7 come down?
I have no idea. I wasn't there.
Well, have you studied that?
Hang on, where we're going now? I thought we were talking about flat Earth. Now we've gone on to
it's all related to the control system that the global elites are trying to put
basically,
over.
once you've got into flat Earth, you've had to go down that many different rabbit holes at the moon.
Got a lot of rabbit holes to go down.
You've gone down all the rabbit holes. The Earth is flat. There's a firmament over the Earth. There's a dome over the Earth. Satellites are fake. Moon landing is fake.
Mm-hmm.
Pilots don't understand how to fly airplanes.
Well, and these asteroids that they claim are coming towards us, it's all fake. They even showed pictures of an asteroid spinning in space. So how did they get the camera to go around that asteroid? It's all a depiction. It's all a CGI imaging of that. So anyway, we're not going to agree, I'm sure, but one of the things I'd like to leave you with is the spin of the Earth and the wind speeds. Why, if the Earth is spinning from west to east so that the sun comes up in the morning in the east, as you spin from the west towards the east, you get to see the sun come up and then go down towards the west. Now, here in the East Coast in Virginia, the winds travel towards the east, pretty much from west to east, a little bit north, but mostly from west to east. That means the winds are traveling faster than the speed of the spin of the Earth. They're going 5-10 miles faster. Now, how can you get a centrifugal force great enough to spin the winds faster than the spin of the Earth? And other days, the
winds are not controlled by the rotation of the Earth. The winds are controlled by the heating of the atmosphere.
And then why do the winds change directions? Some days they change and they go almost the opposite direction.
Because, like I said, the heating up of the atmosphere causes high and low pressure points, and a high pressure will automatically be attracted to a low pressure point. So depending on where the low pressure point is on the Earth, then it will be in a different position. So where that pressure point, where that low pressure is today, in a week's time it'll change, but in a different place.
Okay, well, I'm gonna kick on out of here. It's been fun talking to you, Paul. I got some other things I get done this evening.
I don't actually feel like you've actually spoke to me, apart from just got all these sound bites out that you could.
That's fine. I mean, I cannot spend a lot of time on every single point, or I get bogged down in one particular point. But actually, what I'm showing right there is a sunspot on the clouds. So
yeah, what's strange about that?
Well, because it shows that the sun is actually very close to the Earth. You would not get a directed sunspot below. And look how large the sun looks up at that 121,000 feet compared to what it looks like down below. Anyway.
That's all the satellites.
Do what?
That's all the
yeah.
satellites.
Yeah, supposedly. Yeah, now look, why are they not concentrated around the equator?
They're not. They're all over the place.
Yeah. So why can't we point our satellite dishes straight up?
Because the satellites because every satellite is not there to give you a good TV picture. So all the satellites that are up there to give us satellite TV will probably be based on going around the equator. What's surprising about that?
Well, I could see that if there's maybe eight satellites are specifically for your TV signals, then I'm trying to figure out why in the world they need the other 16,992.
Because they're not all there for you to get TV. Like I've just told you, you've got satellites up there for GPS. So GPS satellites are not giving you TV. Your TV satellites are not giving you GPS, right? Yeah. So that's just two. So you've got GPS satellites, you've got TV satellites. Your weather satellites are not giving you your television signals or your GPS. It's just monitoring the weather. So now we've got three lots of satellites that are up there. Not three satellites, three different types of satellites up there. There is God knows how many amateur radio satellites up there. There was quite a lot, actually. I was quite surprised to find out where there is. So the amateur radio satellites, they're all up there. Again, they're not giving you TV signals. They're not giving you GPS or weather. They're giving you amateur radio.
Yeah. One last picture here. I just came across. It shows.
All I'm saying is yes. You're not addressing what I'm saying to you. You seem to think when you mentioned that you were like, you might only need 8 satellites for.
Yeah, but to me, it just does not make sense. I hear what you're saying, but it doesn't make sense to me that they would have 17,000 up there, and all of them, the rest of them are just for military purposes or government purposes or what. And they claim that they're doing mankind a favor by putting these satellites up there, and Elon Musk is keeping on putting these things up there. Yeah. So, what is going to be the purpose of all that if it's not to benefit mankind normal lifestyle?
I'm sure if you Google what are all the jobs of the satellites, I mean, I've never looked into that. You'll get an answer. Like I said, there'll be weather satellites, GPS satellites, television satellites, internet with Starlink, amateur radio satellites, and all the other different types of satellites that they are up there. You will get an idea of what all the jobs are for all the different satellites that are up there.
Yeah. So this here last picture shows the Earth and the moon passing in front of it. You see a video on NASA, the Discover Epic from over 1 million miles away, looking at the dark side of the moon passing in front of the Earth. They show it like that. And then you also see the top part here. You see the Earth way the hell off in the distance from the little piece of cardboard and tinfoil and duct tape astronaut object that they put up on the moon. It looks like it's barely able to hold itself together. But anyway, they show the Earth way the hell off in the distance away from the moon. To me, this does not look like it's reality. And there's another video that shows the Earth rise from the surface of the moon. If the moon is tidally locked to the Earth, there can be no Earth rise. It should be stationary the whole time. Whatever you see the Earth from the moon,
you
cannot see rise.
No, when you're looking at the moon from Earth, when we observe it, yes, it's tidally locked. So you're only seeing one face of the moon, but the moon actually does rotate.
How much?
When the dark side of the moon is facing towards us, that's the time that we can't see it.
And does it wobble? Just wobble a little bit? It never rotates to where we see the backside.
Yeah, there is a slight wobble. If you look at a time lapse picture of the moon, you will see it wobble. Yeah.
Mm-hmm. So, and like Kelby is saying, Earthrise is taken from orbit. The only way you're going to get an Earthrise is if the camera is moving on the moon. moving toward the Earth or whatever. That's the only way you're going to get an Earth rise. And so, if you had a camera that's
Yeah, but
stationary,
we've already agreed that the moon is rotating. It's just that as it rotates at the same.
I'm saying with
at
reference
the
to the
what
Earth.
it orbits
reference
the,
to the
the
Earth.
Earth. So we always see the one side, but it still is rotating. So you'll still see an Earth rise.
No, if you're in taking the moon with reference to the Earth, if you're standing on the moon, supposedly looking at the Earth, and if there is just a little bit of wobble, you're not going to see a Earth rise continuously. It's going to wobble a little bit, but you're not going to see it rise and rise and rise and rise.
Right. I mean, I've not seen this video, so I mean, I really
just
can't
look it up on the
comment
internet. There's, Earth rise from the moon. I'm not going to stay in here much longer. I got to get on out of here. I got stuff I got to get done. But it's been fun talking to you, Paul. Hey, we ain't gotta see eye to eye. We ain't gotta, convince each other. It's a way to get ideas out there and get people thinking.
Yeah, well,
two sides to every story.
Yeah, I put me. You've got my
Email.
Email and YouTube channel. Send us an email, and we'll get something set up. Because obviously, you've literally just done this on the fly to me. You've really have put me on the spot on this. I had no idea this was going to come up.
Well, some of the things you put me on the spot too. I mean, I had to do some thinking on some of those answers too. That's why I tend to move.
You never answered anything.
That's why I tend to move on to something that maybe I don't know the answer to, and I'll admit sometimes I don't know all the answers. Like we don't have to know all the answers. We just need to look and try to observe for ourselves, ask questions. Don't take somebody's word for it. Do your own research.
Yeah, I totally agree that you should ask questions and you should research stuff. I'm not knocking you for that. It just seems to me that you've gone for the conspiracy thing about. I don't want to sound awful, but flat Earth is seriously the most dumbest conspiracy theory you can get involved in.
Not if you look at the Bible. Not if you look at the Bible and what it tells you.
Oh, we don't have to bring the Bible up when it comes to.
It agrees with the Bible. It's in 200 verses of the Bible talks about how the Earth is immovable. It's basically
for argument's sake, if we can prove to you 100% that the Earth was a globe, would that make any difference to your belief in the Bible?
Well, I probably would throw the whole Bible out if I could agree with you, because Joshua told the sun and the moon to stand still, not the earth to stand still. So just things like that. The New Jerusalem coming down out of heaven, landing on the earth. It would have to be landing on a curved earth. You would have to have 77-mile high columns at the two outer edges to support a New Jerusalem that's 1,500 miles wide. Just things like that. It talks about a bottomless pit on the earth. How can the earth be bottomless pit if it comes out over in China? That's not bottomless. That's just a shaft through the middle. But a bottomless pit means it goes straight down and goes down forever. Just things like that. It just agrees.
Yeah, you don't realize that the people who wrote the Bible were ignorant to the science that we have today. And the knowledge that we have today.
I think God knows better.
Not if you read the Bible, you don't have a clue.
Yeah, I'm gonna send you a test email here before we get out of here. Just see if can you check your email and see if you get the email from me.
Yeah,
it's like this 1, 2, 3, 4 flat Earth. See if you got an email from me. Make sure I got the correct one.
Yeah.
Hey, this guy Paul Kamish doesn't believe in the Bible. That's the thing.
I know. I'm just trying to say flat Earth
yes, I've got it.
Helps.
Oh, you're called Paul as well.
Yeah, my name is Paul.
Yeah, brilliant. Yeah, I've got it. So yeah, no worries, mate. We can.
I don't announce my last name on the internet, but yeah.
No. I won't.
Cool.
I won't dox you. Don't worry about that.
We're more likely to get hit by an EMT attack from the sun than anything.
Yeah.
And then it's going to be scary because we're not going to be able to communicate.
Yeah, that is absolutely a possibility. Yes.
Well, they're probably going to do away with a lot of our cell phones.
It'll knock cell phones out. It'll knock radio transmissions out. It'll knock all your. It can even knock our electricity off.
Oh yeah.
You know, right now we're using the internet to talk. How can we let each other know what's going on if that happens?
Well, if that happens, we aren't going to be able to let each other know what's going on. It's too late. It's happened.
Yeah.
But it depends on it. You know, it might only last for a short period of time. It could actually only last for a few hours. It depends how big it is, how big the solar flare is.
All right, guys, I'm going to get on out of here. Good talking to you guys.
Yeah. All right,
Right,
Ben.
take
It's
care.
been a pleasure talking to you. Like I say, I've got your email now, so
Okay, cool.
yeah, we'll have to arrange something. We'll have a chat.
All right, 10-4.
Yeah, catch you later, fella. Right, I suppose I best go as well. It's 3:30. Did you find that interesting?
Yeah, it was pretty interesting.
You're not a
How
flat earther.
how likely you think it's going to happen within our lifetime?
Yes, I think it is. We'll certainly have some sort of solar flare event. Depends how bad it's going to be. I can't predict that, but it absolutely is a possibility. Yes.
It's really sad to say, but I hope it happens soon because the way the world is these days, man, I can't wait for it to finish.
What? You want the world to finish?
Yeah, I mean, what's the point of it going on like this? It's getting worse and worse.
What's
The cost of living, just wars, people dying.
No, we have less wars now than we have done probably in any other time in history.
I don't believe that.
People are living longer than any other time in history. People have a higher standard of living now than any other time in history. You've only got to go back 100, 150 years ago. 90% of the world's population was living in poverty 150 years ago. Now it's probably the opposite way around. Probably 15 to 20% of the world population is living in poverty. So that's completely different.
Well, you know, I say more money, more problems.
Yeah, but you know, see what I'm saying now? It's you'll think back to 150 years ago. The majority of people lived in poverty. They just had enough to get by.
But they were happier. They were happier without all the things in life.
How do you know they were happier? What says they were happier?
They had less to worry about.
Well, that's your perspective looking back, because we always look back with rose-tinted glasses. I bet if you speak to the people that were living in them times, that they will probably disagree with you. I don't know how you can tell that they were happier.
As long as they had food and they had the roof over their head, that's all they needed. They didn't need think of it this way, man. With technology, okay, it comes convenience, but it also comes other things too. Like back in the day, it was really difficult for your wife to go cheat on you. But now she just has to open up her application and she's got options globally talking to her. That's just one example.
Yeah, but you've also got, you can show that. I don't know why you said that your wife's got more of an opportunity to cheat on you. You've also got more of an opportunity to cheat on your wife, haven't you?
Exactly. So more money, more problems is what I mean.
No, not necessarily. No, because the fact that I've got more opportunity to cheat on my wife, I don't want to cheat on her. So it doesn't matter how much opportunity I've got. It doesn't make no difference. So just because somebody doesn't have the opportunity, they're not really a decent person anyway, because the opportunity hasn't come along. They're not going to take it. You get what I'm saying? So if you're saying that just because they don't have the opportunity, they would still do it if they had the opportunity.
Back then there was no opportunity, is what I'm saying.
Yeah, but they were just as bad as the people who nowadays have the opportunity. Just they didn't have the opportunity. They've still got the same mindset. They would cheat on you as at the drop of a hat.
What about morally speaking? You know, I know you're not religious, but back then it was considered something horrible to do. Right now, it's socially accepted.
No, it's not. I wouldn't find it socially acceptable for my wife to cheat on me, and I don't think she'd find it socially acceptable for me to cheat on her. I'm sure my kids would think it was socially unacceptable for me or my wife to cheat on each other. My neighbours would think it was socially unacceptable if they found out that I was cheating on my wife or found out that my wife was cheating on me. So how is it more acceptable nowadays? It's still not acceptable nowadays to be cheating on your partner.
It's because of exposure. That's why. Because we're so
It's not
exposed.
acceptable. It's still not acceptable.
Really, you don't think society accepts it more than they do before?
No, I think it's still frowned upon. I mean, I don't know what you want society to do about it. At the end of the day, it's nothing to do with society. It's to do between you and your partner. It's how you deal with it. I mean, whether it was 100 years ago, if I found out my partner was cheating on me, I would finish with my partner. Today, if I found out my partner was cheating on me, I'd finish with that. We're done. We're finished. Whether it's today or 100 years ago, it makes no difference.
Everybody says that,
would
but
it-
it's
I
a
would- I
lot more
would-
complicated than that.
No, it's not. How is it more complicated than that? If my wife cheats on me today, I'm done. I don't want now to do it.
Do you own a house with her?
Yes.
Okay, so let's say, God forbid, she does that. Okay, just metaphorically speaking.
Yeah.
And you say, I'm done with you. There goes
Yeah.
half your house.
Yeah.
There
So-
goes half your life. There goes half your assets. There goes half of everything you worked hard for.
Yeah, and also my marriage is over and done with, so that half of my life is finished as well. Yeah. But
So
the same as if it happened 100 years ago, exactly the same principle standard.
no, man,
All right.
because
I might not own the house 100 years ago. I might not be in a position to own my own house 100 years ago. But everything else is still the same. I'm still finished.
that's why I say it's easier said than done. Because let's say if that happens to you, would you be willing to say see you later so fast?
Yeah, I wouldn't want to be with her. If my wife cheats on me, that's it. We're done.
Even though you'll lose half of everything?
Yeah.
And then what? You'll restart again?
Yeah, I'd have to do. Yeah. I don't get your point. Cheating on somebody is wrong today as it is 100 years ago. There's no difference.
Well, 100 years ago, the cheating spouse would get stoned alive. But in this modern day society, it's not illegal.
And you think that's acceptable then? So you think that's acceptable that 100 years ago, that if your partner cheats on you, they get dragged out into the street and get stoned in the street? You think that's a good society to live in? Would you actually want to live in a society that was like that? So you hear a load of noise down, you think, what's going on? You open the curtains and look outside, and
It's not nice to live in a society like that, but it deters a lot of people from doing.
That's the other question: is that the woman gets dragged out into the street for cheating on the husband and gets stoned to death. If the husband cheats, does he get dragged out into the street and get stoned to death for cheating on his wife?
It should be.
And you'd like to live in a society like that?
It's not nice, but it deters people from doing a lot of things.
Would you rather live in a society like that, or would you like to live in a society that would actually, it's a criminal offence to do that? Which is the better society to live in? The society which stones somebody to death for cheating on the partner, or a society like now that actually protects somebody if that was to happen, that they would not be allowed to get stoned to death?
That's what I'm saying. They don't protect in this modern society because
which is a better society? Which is the better society?
It's not illegal to do that in this modern day society.
What, to stone somebody to death?
No, I mean cheating.
Right. So why should it be illegal? It's between you and your partner.
Because it fucks up your life. Based on their selfish decisions, it fucks up your life.
Yeah. So let's just say that your partner doesn't cheat on you and just decides that the relationship's over and walks out on you. What's the difference? Your life's still fucked up exactly the same.
I think it's a lot worse when they do that, because if they walk out, they walk out. But if they cheat and then you're forced to walk out, it's different because they betrayed you.
If your relationship's over because your partner cheats on you, or the
Okay,
relationship.
let me put it this way: when you got married, did you take a vow?
Did I think of?
Did you take a vow when you got married? Did you say your vows?
Yeah.
Till death do us part. That doesn't mean anything anymore.
No, I don't, in fact, nowadays I don't think you need to say that. I can't remember the exact vows that I took actually, so I can't remember what was said. But yeah, you promised to, yeah, with the partner. But no, somebody shouldn't be forced to stay with somebody if the relationship isn't working. I don't think that somebody should have to stay.
See, that's the difference between non-religious people and religious people, because if they decide, it's there, nobody forced them. If they decide to marry someone, then they better be in it. Unless if the person cheats or they do something crazy.
Yeah, but obviously when you get into a relationship, whether it's a marriage or whatever it is, until you actually get into that relationship and actually live with somebody, you can't really, you don't know what it's going to be like. You meet somebody and they seem absolutely perfect, but when you actually live in the little annoying things that they do that really pisses you off, and little things that you do really get on their nerves, and the relationship just doesn't work. But you're not going to know that till you've tried it.
There should be a difference between boyfriend and girlfriend and husband and wife. Husband and wife, they have to deal with those little things that bother each other and work on it.
Yeah, and most people do, but sometimes a relationship, a marriage can break down for whatever reason. Do you not think it would be a horrible society that if somebody's living in an abusive relationship, and it can be both sides, women can be as abusive, it doesn't have to necessarily be physical abuse, but whether it's physical abuse, mental abuse, or whatever it is, do you think that somebody should be forced to stay into a relationship? They get married at 24, 25-year-old. Do you think they should be forced to stay in that relationship until the day they die? Which could be
like I said, either if they're cheating or if they do something crazy like abuse, then it should be okay. But I feel like marriages break up these days for very little reasons.
Yeah, and I suppose that's down to the individuals. If they no longer want to be in that relationship, then somebody should have the right to leave that relationship.
And it seems like it's no different than boyfriend, girlfriend, and married couples, because the smallest thing let me put it this way. Like, a lot of people are saying, my wife got bored with me. I mean, is that a reason? I mean, what do you mean? My wife got bored.
I mean, at the end of the day, you don't have to have a reason, really. If you feel as an individual that the relationship is over, as trivially as that reason might be to another person, it doesn't matter. It's your reason that you want the relationship to end. So you should have a right to end that relationship.
So what right do you have to marry that person then? Why did you do that in the first place?
You have the right to marry somebody because it's an agreement that you both have. So you both agree to get married. But any one of you at any one time can get out of that relationship.
And then you could say, "Oh, I'm just bored with you. I'd rather go fuck another guy or fuck another girl, or I'd rather."
No, I wouldn't think that would be a good
reason.
Know,
your accent pisses me off, so therefore we're no longer together, for example. All these stupid reasons.
Me personally, I don't think all them reasons you've given is a good enough reason to end a relationship. But everyone's relationship is individual, and if they feel that the relationship is over, regardless of what the reason is, it's over.
Do you spend a lot of time in your office talking to YouTube?
Occasionally. I haven't been actually on YouTube talking to anybody for several weeks, actually.
That's a reason right there. A lot of marriages split up because the woman says, "You don't spend enough time with me," and then another scenario is, "We spend too much time together. You get on my nerves." It's like you can never win.
Well, I mean, I've been married 35 years this year, so I've done something right. I don't know what it is, but I've done something right.
Well, what is it then? See, you got to say.
I don't know.
You have no idea.
I have no idea why it works. No. just does. So.
You guys never have any arguments?
Oh yeah, of course we do. Everyone argues at some point, but the way I look at it now, in being a bit long in the tooth, so to speak. I don't see the point in arguments. Most arguments in a relationship, when you think back at them, you've been married a few years, you think back about the arguments that you've had, you can't remember what the arguments were about. So therefore, they weren't even worth having an argument in the first place. Well, pointless.
Yeah. It's just different when the argument keeps going on and on and on for years. The same argument.
Yeah, I mean, I've never experienced that. I mean, to me, it's over now in the summer. Silly little thing that I don't know. Can't think of anything.
Let me ask you this: whose family, okay, your side of the family or her side of the family, was more helpful in your marriage?
Probably about the same.
That's why it worked out. Because if the families are both similar and they're both helpful and understanding, and it works out. But if one side, their family is helpful and understanding, then the other side feels bitter about it.
Yeah, I could see that. Yeah.
And I read this thing. It said, when you marry someone, you're not just marrying them; you're marrying into their family. And if the families are a match,
yeah, I suppose to a certain degree you do. But I mean, I don't allow my family to really interfere with my life, and the wife family doesn't really interfere with us either.
I'm sure they did at the beginning, not to interfere, but just to help out, to help you guys get on your feet when you're newlyweds.
Yeah. I suppose, they were both probably about equal then. I mean, I've only really got my mother on my side now. My father died a few years ago. I've got my brother, my sister, my mother, my wife. She's got both her parents, and three sisters and a brother.
And the families get along. Her side and your side, the families get along.
No, to be honest, my side of the family don't really see much of her side. When they come together, they get along, but it's they don't have any sort of like thing to do with really the other side of the family. So,
but when they are together, they get along.
Yeah. I mean,
that's important.
We just don't live in each other's pockets. It's as simple as that. I see my side of the family. My wife, she sees her side of the family. They all turn up here every now and again to visit. And just that's it. My mother, she lives 7 or 8 miles down the road from where my wife's family live. So the two don't ever meet up, so to speak.
What do you mean they're not in each other's pockets?
It's not like they turn up every 2 or 3 days or anything like that. I mean, it can be several weeks pass by before I see anybody from outside of basically just me, the wife, and the kids.
Yeah.
I mean, the wife's just been away this weekend. She went down to London for 2 days. She went with her mother, a sister, and a nephew. So she spent two days with them down in London. So yeah, we see the family, but like I say, it's not. It could be another 2 weeks before she sees them again next. Or she might see him at weekend. There's no rule to it.
Are they staying at a hotel?
Yes.
How do you trust that, man? As good of a guy as you are, and as good of a woman as she is, how do you know?
Well, for a start off, she was there with her sister and her mother.
Well, that helps.
Yeah. I mean, her mother's not going to have a right good opinion of her, and nor the sister if she did something. You know what I mean? It's like if I was going to go on, if I was going to have a break and go down to London, and I went with my dad's side, but say if it wasn't, and I went with my dad and my brother, if I was to do anything, my dad and my brother ain't gonna have a very good opinion of me, am I? Are they? So
Yeah, but they're not always together. I mean, what if she goes to the bar? What if anything? I mean, of course, it goes back to trust, right? But you can only trust so much. The person has to be a good person.
yeah.
And like you would never do that because you just wouldn't.
No. And I trust my wife 100% that I don't think that she would. To the point where if I didn't trust my wife, if I was thinking, oh, I don't really fancy her going away for the weekend because I don't know what she's going to be up to. As far as I'm concerned, you might as well end the marriage now before she even does anything because the trust has gone. Forget it. Forget the relationship.
That's what my dad said too. He said if you can't trust in a relationship, there is no relationship.
Yeah, and I trust it.
It's just so tempting these days. It's so much easier. There's so many options. There's social media. Like,
yeah, I mean, I'm not tempted by it. I've got no interest in it.
Yeah, neither am I. But women think differently. That's what I figured out. As good as they are,
yeah, there's some women.
They think emotionally.
Well, men do to some degree.
If a lad gets into her head and gets her all emotional, let's say you think everything has been good for all these years. But what do we know as men? Women are strange. Maybe what we think is good, to them, it's been horrible. And they'll never tell you. That's the problem. They'll never tell you. They'll never tell you it's been horrible. They'll just say, oh, hi, honey, how are you? How's everything? Good, good, good. But really, deep down inside, they're yearning for that emotional connection that we have no idea about. No idea. If that makes any sense.
No, I think you've got a lot of trust issues when it comes to women, by the sounds of it.
I mean, they don't help ease my trust by the things they say, the things they do, the things they get caught doing. And you're from a different generation than me, for sure. But the new generation, it's like, they don't give a fuck almost anymore. They'll just do and say whatever they want. They'll tell you, yeah, and then go behind your back and tell their girlfriends, oh, yeah, I'm so bored. I can't wait to get out of here. And then they see some like hot-looking pool boy, with a six-pack, and next thing you know, the guy says something to them, and they're in their room.
Right. I mean, that stuff's gone on since the dawn of time, I presume. It's not just women that do it; blokes do it as well. I mean, who's more to blame? Do women cheat on the fellas more than blokes cheat on the women? I don't know.
The way we do it, it's different. I guess it's just for sex. But the way they do it, they get an emotional connection out of it.
You really think that's an excuse? Ours is just for sex. Really?
When guys do it,
it's just for sex. I don't think I'd get away with that if I got caught. Oh, Trace, what's the matter with you? It was just sex.
Because, I mean, if metaphorically speaking, let's say you were to do that, which I know you would never, but let's say if you did, would you do it to emotionally connect with somebody? Or would you just do it to bust a nut?
Well, you can't answer that question, can you, until you actually meet the person that you'll have to do it with. It could be somebody you're actually not just physically attracted to. You could also find them mentally stimulating as well. I don't know.
Really?
But anyway, time's really cracking on. I'm only going to get a couple of hours sleep, and I'm going to have to take the missus to work.
You're going to go? Okay. All right, man. It's been good talking.
Really am. Yeah. So I'll catch you on the next one. Like I say, time's rattling on. It's 4:00 in the morning, so I'm going to have to shoot off.
Oh, wow. Okay. All right, man. All the best.
Yeah, Andrew, fella. I'll catch you all later. Everybody in the chat, catch you all later. Ta-ra.
Ciao.
Oh, right. I've forgotten about that last bit at the end. Yeah, Numi seems to have some sort of issues with women. proper issues. Yeah, totally forgotten about that bit. So yeah, I was watching that, and yeah, I wasn't expecting it. Yeah, he's got some proper issues there when it comes to women, hasn't he? I do remember when I was having the conversation last night with him. I was trying to be really polite, but I found his questioning very. I don't know whether he's had any issues. He must have had some issues with women, but his opinion on women was very bad. It certainly was. Anyway, this has been on for 2.5 hours now. So if you've managed to stay right till the end, you need a medal. I doubt if many of you managed to watch this all the way to the end. But anyway, that's it. So I'm going to end this stream here. Hope you enjoyed it, and I'll catch you on the next one. And I'm going to put my intro back on again. So I'll catch you all.